So one of the things that we need to do, whether we're a technician or just someone trying to work on our own vehicle, we need to be able to identify the vehicle correctly. And one of the mistakes that's made by both technicians and people trying to work on the vehicles themselves is they do not identify their vehicle correctly, and therefore they get the incorrect parts. Where a part may even fit, it may even look correct, but it's not correct in some cases. Other times it's nowhere close, and you're wondering why you get the wrong part. And at the end of the day, many times it's because the vehicle is not identified correctly. We cut a corner, and even with everything that we talk about, there may still be additional information. So, for example, I had to order some cooling system components for my car, and I gave them the vehicle identification number and a list of parts. And I still got a text back asking me if it's a hybrid vehicle, because even with all the information that I gave them, they didn't know if it was a hybrid or not, just based off of the VIN and off the year, make, and model, and so on. They needed more information than that. I didn't think that. I thought the VIN would give them that, and it didn't. So then there's a choice, one way or the other, right? And a lot of times, what happens when we're at a parts house is they just make the choice for us and don't ask. Or if they ask, we just guess because we don't know. And certainly if your vehicle is a hybrid or not, you're going to know that. But there's a lot of other more subtle things, like, is your vehicle a California vehicle or a federal vehicle? Does your vehicle have a transmission oil cooler? Does your vehicle have fill in the blank? So we're going to talk about some of the different service information we have, and also about actually IDing the vehicle itself. So we're going to be looking at both of those things here on the PowerPoint. And let me move this over for a second. Well, you think 3 screens would be enough, but sometimes I wish I had 4.
Good morning, sir.
Good morning.
Yeah, I'm Florian Morelos.
Good morning. Glad you made it.
Yeah, thank you.
You bet. So one of the first things we look at when we talk about vehicle information is service information. So service information, I'm going to refer to this quite a few times in class, may have details on how to diagnose, repair the vehicle. One of the things I'm going to discuss a lot is most service information does not tell you how to diagnose the vehicle. They may have things in there called flow charts, which give you a diagnostic path, but they are not. They're not necessarily going to tell you how to diagnose the vehicle. So, for example, if you have a brake light out, there's no manual out there that's going to tell you how to diagnose the brake light that's out. Your car's running rough. There's no manual out there that's going to tell you how to diagnose how your car's running rough. If you have a diagnostic trouble code, there may be a diagnostic procedure for that trouble code. There may also be other diagnostic suggestions based on symptom. In other words, your car runs rough, we'll check, spark, check fuel, check compression, check. It's really not a diagnostic path. It's just a list of possible things you might want to check. So sometimes people have an unrealistic expectation of what's in repair information. What repair information is going to have specific information many times for that vehicle, how that vehicle is wired, how a system may work on that vehicle, things that give us pieces to apply what we know in order to diagnose the vehicle. And that's where that electrical foundation we're going to be doing in this class is so important, because with that foundation, now I can go and look up and understand what I need to do. If it's an R&R thing, if I need to remove and replace something, then odds are there are some step-by-step procedures. Not for everything, but normally for more major things or things that are not common among all vehicles. So in other words, there's not going to be a procedure necessarily on how to replace a brake light bulb. Figure it out. but there would be a procedure on how to replace a water pump because that's something that's more involved and very different. I'm going to see some specifications, so torque specifications, electrical specifications, potentially diagrams, some exploded parts illustrations, some troubleshooting charts. So there are some computer-based diagnostic services that most shops have. Mitchell is one manufacturer of information systems. They made books forever, and then they went into digital information in the 90s. ALLDATA, which was really the first digital information system for the aftermarket. And you used to actually buy ALLDATA. It came with its own computer and everything. So this was in the early 90s. Had thermal paper and the whole thing, and it was just a huge advancement over the books. And Mitchell spent a couple years catching up before they came out with a digital format. Identifix has some manuals and some information in it. It's largely statistical analysis based on what technicians are normally finding with a specific fault, and it's usually some quick test procedures. And then IATN stands for International Automotive Technician Network. And that is actually you can have it as a paid subscription or a free subscription. The other three are all paid subscriptions. And they have forums on there where you can discuss different topics. You can post things that you're having a problem with and perhaps get a helpful feedback. They also have different libraries on waveforms and other things available in that. So that is the information systems we use. Other places we look would be the owner's manual. There's certain information that's only available in the owner's manual. So for example, how to set the seat memory is only going to be in the owner's manual. How to flip through the key fob with the lock and unlock buttons in order to change whether my car automatically locks itself or not. That's all in the owner's manual. That's not in the service manual. So if I have a customer comes and complains, yeah, I got locked out of my car now, locks itself automatically. It never did that before. But what the customer did is they inadvertently bumped this with the door open, and it changed the setting on the process. But since customers don't read their 700-page owner's manual, in their mind, the car is broken. So even if I have all these other repair information, I'm never going to find out how to fix it because it's a normal function. It's something that the system is designed to do, and it's in the owner's manual explaining that. So everything from adjusting the clock time, all of those things are in the owner's manual. Now, owner's manuals come with the vehicle. They are also available online at most manufacturers' websites in the form of a PDF. So you actually have some manufacturers now that are no longer giving a paper owner's manual because they're heavy, they never get read, and they're just going to a digital only copy. Many manufacturers still have a printed owner's manual, and it's available online. Then we have a flat rate manual. We talked about that a little bit yesterday. So a flat rate manual could be a separate book. Matter of fact, the first books I bought from Mitchell for the first shop I had back in 1980, I think, or 83 manuals, was flat rate manuals. So I could price things out. I already had some other repair manuals and other information. I needed flat rate manuals. Now that's built into Mitchell or ALLDATA. Technical service bulletins. What technical service bulletins are is they are a bulletin designed for dealership technicians to advise them that there is a problem with a specific set of vehicles, and normally not to follow the normal diagnostic procedure, but to do something different. So it may be, hey, a car comes in for this code, check to see if it has the part with the blue stripe instead of the part with the yellow stripe. If it still has the part with the yellow stripe, then put the blue stripe in. If it has the part with the blue stripe, then diagnose as normal. So many times manufacturers will do color coding or things on their parts as they improve their parts because they've had a manufacturing issue. And that way they put out a TSB telling the technician to, hey, go look, see if it already has the new part. If it does, diagnose it. If it doesn't, put the new part in before you do anything. Because dealers have found that it's cheaper to put that new part in than it is to pay for diagnosis. It may also be that, hey, there is a problem with manufacturing, or a part from a component was wear out. So maybe only if your truck was made at the St. Louis plant, we had a problem with heater core. So if you have a heater core problem and the truck was made at the St. Louis plant, get the updated model, do this. So we see a lot of that kind of stuff. So technical service bulletins are not a free repair. All they are is designed to help dealer techs diagnose the vehicle. Now, if the car is under warranty, then the repair would be free. But they're not a what we call a recall. So we have three different things. We have a safety recall. That's where the manufacturer recalls a vehicle because of a safety issue, normally because NTSB requires them to. So that'd be your car stalls in the middle of traffic and 3 people have been killed. We need a safety recall. Safety recalls are always free. The next thing we have is called a campaign. So that is where a manufacturer notices a problem with something. So for example, the transmission on my car. They noticed they were having a problem with the transmission on my car. So what they did is they had a campaign where they extended my warranty on it. There was a software update for the computer. And if my torque converter failed within the warranty period, they would put a new torque converter in it, which was what the campaign was designed to do. So this is basically the manufacturer coming out and saying, hey, it's not a safety issue, but because we're great people and we care about you, we're going to do these things for you. So this is not for the technician, this is for the customer. So the first two, the recall and a campaign, are both directed at the customer. One is, hey, it's safety, you need to get this fixed, like the Takata airbags. The other is a campaign. Hey, we care about you so much, we want to take care of this on your car for free. Toyota is great at doing campaigns. GM pretty much never does campaigns. So this is really kind of how they react with the consumer. A technical service bulletin is just for the repair technician. They're not meant for the customer. They're strictly meant to help the technician diagnose specific things. Don't underestimate the power of Google, YouTube, etc. There is a lot of horrible information on Google and YouTube, but there's also some good information on Google and YouTube. So a lot of it comes down to, you need to do what? Really kind of look through and consider the source. I see a lot of chat and forums on Google where people are talking like they know what they're talking about and they don't have a clue. I see a lot of YouTube videos where it's a wonder the person's still alive and they're doing a lot of just dumb things. On the other hand, there is useful information. So I don't discount it completely, but you do need to be careful of some of the stuff that's out there. So I'm going to change my screen I'm sharing here. So I'm going to go to all data first. And show you what that looks like. And then we'll go to Identifix. I have Mitchell. I never use Mitchell. I mean, once a year, Mitchell may have a spec I need, but Mitchell's just not terribly user-friendly. And I know when we were on campus and we were looking stuff up on cars, I'd tell students actually in the instructions, go look this up in all data. They'd go to Mitchell because other instructors use Mitchell. And they come back, I can't find it. Well, you didn't go to where I told you to find it. Having worked as a technician for a lot of years, I can tell you in the shop, I use all data. I don't use Mitchell because there's a lot of things in all data that aren't other places. So let's pick a vehicle. I'm gonna go 2015. What, Toyota sells a few cars, right? Let's go Toyota truck. And let's go with a Tacoma. And I can see my engine choices. Let's go with 4-liter. And so now I have all these categories. So I have diagnostic trouble codes, service tables, technical service bulletins, diagrams, specifications, parts and labor, and maintenance all over here on the left side. But then I can also look things up by specific systems. So this is fairly logical, especially once you get used to it. But say I want to look up something for my engine. So that would be powertrain management. And we can see here that I have computers and control systems, emission controls, fuel delivery, ignition. And this tells me I have repair information, parts and labor information, where there's TSBs, and where I have specifications. I can also go over here and look at diagrams. And this provider gives me the OE diagrams as well as the aftermarket diagrams. So there's 2 different types of electrical diagrams. We'll see when we get in the electrical section. And they each give us some different information. I can also go into parts and labor. So if I go into the ignition system, for example, now I can see spark plugs, NOx sensor, camshaft sensor, and so on. So let me go to spark plugs. And in this case of spark plugs, it's going to give me the parts and labor. How much labor does it pay? Oh, It pays 1.9 hours to change the 6 spark plugs on this car, and it's a skill level of B. Remember I talked yesterday about A, B, and C skill level. So that is my parts and labor. I can also look at remove and replacement. So it's going to give me a procedure to remove and replace spark plugs. Sometimes this is very lacking. Sometimes it's very complete. So here we have removal and installation broken down separately. Most new procedures, that is separate. If I go to an older vehicle, you're going to see a removal procedure, and the last step is reinstall in reverse order. What we see normally on vehicles today is a lot of times, especially when we talk about engines, those procedures are completely separate because you're no longer reinstalling in reverse order. There are some specific things they want you to do or some specific differences as part of that reassembly. So if I look at removal here, it tells me I need to disconnect the negative battery terminal. Well, first of all, going back to the 1960s, that's been step one for almost every instruction. And let me tell you, no one does that in industry. There's no reason to. And actually, there's a lot of reasons not to that we'll get into when we get into computer systems. So the whole reason why that's there is to prevent someone else from coming up and turning the key while your hands are there. So this is a safety thing. This is not a protect the vehicle thing. This is keep someone from coming behind you and turning the key and running your fingers through a belt or something like that. So the reason why they put that there is for safety. So when you look at these different instructions, you kind of got to ask, why is that there? Well, if I'm working by myself, I probably don't need to disconnect the negative battery cable because I'm not going to reach around and turn the key while I have my fingers in the engine. A, I'm not that long, and I'm probably just not going to do that. But that's why that direction is there. Because again, keep in mind, manufacturers write their directions and a lawyer looks at them. So if someone can get hurt and you didn't tell people to disconnect the negative battery cable, now what? They're responsible, right? So, you know, I go back to my old 1960s Chilton book. Step one, remove negative battery cable, you know, put a light bulb in, remove negative battery cable. I mean, it's, you know, step one and everything. So in industry, we don't do that for the most part, unless there's an actual reason for removing that battery cable. In this case, there isn't. It goes in, talks about you need to remove the throttle body, remove the V-bank cover. So what is the V-bank cover? Well, this is nice because I can link on this and I can go, oh, it shows me, oh, they're talking about a timing cover. Whoa, okay. So remove air cleaner assembly, disconnect ventilation hose, and you can see where the spark plugs are, and you don't need to remove a timing cover on this one. Remove ignition coil assemblies, remove the spark plugs using a 16mm or 5/8 wrench. So it talks about removing the coils, removing the plugs, and what you need to do. This is a pretty easy job. This job's about 20 minutes to do when you've done it a lot and have the right tools. And you, like I said, it's pay 1.9 hours. It pays a lot more. And that's just, some jobs are like that. Installation, it goes into installation. Now it gives you your torque specification for the coils, and then reconnect the covers and insulation. Connect the cable to the negative battery cable, even gives you a torque for that. Inspect ignition timing, which is kind of funny because it's not adjustable. You didn't do anything to change it, and it really can't be checked. Inspect idling speed, again, not adjustable and controlled by the computer. So sometimes the instructions, it's like they've cut and pasted stuff for the last 20 years. And it's stuff that doesn't even apply to the vehicle you're working on. So consequently, something like spark plugs, technicians normally don't look up the instructions in. On the other hand, if I back out a little bit, let's go to engine. And let's go to, see, timing. Get down to T here. Timing chain. Wow. Now parts and labor for a timing chain on this is 11 hours. And that's for the 2-wheel drive. Plus air conditioning. Plus if you're doing the crankshaft gear. So 11.2, 11.3 hours. Service and repair, I can back up or I can get it right here. So here we have the components, removal, installation. So components gives me a picture. So this can be kind of handy if I'm not sure the different pieces they're talking about on the process. Boy, you gotta get pretty involved. I gotta take apart the inside of the truck too. Remove the upper plenum, alternator. You can see why it's 11 hours. So this kind of walks you through, you taking the oil pan off. There's my front timing cover. And now I'm finally down to a timing chain. And we got some reassembly. So you can see there's just a lot of information here that we're doing in order to get to that timing chain. So they've given you a lot of pictures here so that as you're going through the instructions, you have a point of reference either during assembly or disassembly. Removal again comes down. Here, discharge fuel system, remove battery. Well, in this case, we do want to remove the battery. We need it out of the way as well as we don't want any battery power here because I can't have the engine walking around. So it goes into removing coolant, oil. Oh, remove engine assembly. So here's one line, but I bet you there's a lot involved with removing the engine assembly. What I can tell you is we do not remove the engine assembly when we do these in the shop. You can sneak this in and out without pulling the engine. Remove the oil level gauge, belts, and it goes down and gives you all. So, I mean, you see just a tremendous amount of information here on how to do this job. So you can see where it can get very, very involved. So much more complicated skill. And I don't remember what was the labor. I think this is an A tech. Oh, it's still a B tech. Okay. So again, a lot more time, a lot more effort. So one thing is look at the time. How long does it think it's going to take me? And then I'm going to look at the instructions and see how involved it is. If you notice, there's two times here. There's a warranty time and a standard time. The standard time is what the customer pays. So they call that customer base pay time. And a shop may even charge a little more than that, depending on the job. Sometimes that gets pushed down. The warranty time is what they pay techs at the dealership to do this while it's under warranty. So if you work for a dealership, you're going to get 8 hours instead of 11 hours if the dealer is paying you to do the job instead of the customer. And the reason for that is they figure the dealer techs have done it so many times, they're much faster at it. Plus, it's just what the manufacturer have always done is they kind of try to balance their checkbook off of the technician in the shop. So they've always had lower warranty times. So that is a dealership warranty time. Aftermarket uses this time as a guide. What I can tell you is this is a big job, and in 11 hours is not enough. It used to be 14 hours. So a lot of times shops start doing a job and you'll see the labor time get lower because the manufacturer is doing it and has pushed the labor time down, the warranty time down in order to save money. And the aftermarket many times doesn't respond because it's still the same job. We don't work for Toyota. So you will see some shifting and changing in that. But this is a healthy job. So let's get back to our vehicle here. So diagnostic trouble codes. I have the ability of looking up different diagnostic trouble codes. And I can see, you know, for example, P codes, which are powertrain codes. And then I can look up all the different powertrain codes it has. And I go 335 crankshaft sensor. And it'll give me a little bit of information here. So it tells me what it is, what the computer saw, possible trouble areas, gives me a comparison of a waveform so I could do diagnostics using a lab scope. And then it also gives me some other testing here. So it talks about the strategy, talks about how it goes through and how to confirm the pattern. So this is very, very different than how Mitchell does it. Mitchell is going to give you a chart that says, do this. Is this good or bad? Now do this. Is this good or bad? So you have no idea where you're going, but you're following something that someone else wrote. And at the end, it gets to replace with known good part and retest. It isn't necessarily telling you that a part's bad. It's saying, hey, try putting a new part in because you've got this, this, and this. Where what this is more factory information. This is more, this is how it works. This is what the computer saw that made it unhappy. Here's what normal looks like. Go figure out what's wrong. So you can see one really relies much more heavier on the technician and having those fundamental skills. The other is, how do I replace parts for dummies? Basically, how can I just go through, not know where I'm going, and it's going to tell me eventually to put a part in. And that's probably the biggest difference between Mitchell and ALLDATA when we look at code diagnostics. So we'll find in this class that a code is a symptom. It's not a diagnosis. So even here where I have a camshaft position sensor code, it could be caused by open or short, crankshaft position sensor, crankshaft sensor plate, ECM. It could also be due to a timing issue. Could be one of the teeth on the sensor plates broken. There's a lot of things that can cause that. It can happen because these are not in time with each other. So just putting a part in is not a solution. I need to understand what it's doing, and the best way to test it is here with a waveform. There is other tests where I might use an ohm meter or something like that, but that can't tell me if the part's any good. So this is just one example of a diagnostic trouble code. So we have these code charts for all kinds of things. We also have maintenance in here. If I look at maintenance, I can go to, let's go to a severe, let's see, normal service table. So this right here can show me, hey, at 15,000 miles, what should we be doing on this vehicle? Hey, replace the oil filter, replace the oil filter, rotate some tires. If I come up here to 30,000 miles, then I see the air filter gets replaced. Let's see, spec. And it comes down, replace the oil, replace spark plugs at 30,000 miles, rotate tires, and inspect everything else. So it gives me a service schedule based on mileage. And it's also going to have other things in it, such as routine service, where we're going to talk about checking certain things or possibly replacing certain fluids at different mileages. You can see there's a lot of things here to look at levels and inspect. It's just part of that routine service that's also kind of built in. We also have what's called severe service. So vehicles, and we'll get into more of that when we get into lubrication and how severe service will tighten up the service intervals on things requiring more maintenance. So we have, all this information here. So this is ALLDATA has, and I call it some data some days because that seems like all you get is some data. But I also have like wiring schematics, everything in here. So anything I kind of want to know, this is my go-to place. Another place I go to is IdentiFix, or sometimes called IdentiGuess. And so I can put a vehicle in here and look for a specific problem. So let's go with, let's go 2012 Toyota Camry. I think they sold a few of these. CSE, see there's a lot of Camrys, 2.5. I select the vehicle and I can put in something to search. So the top things that are searched for this vehicle is transmission, this code, this TSB, the junction box, which is electrical, and vibration. So I'm going to click on transmission. So I can search by a keyword. And when taking off from a stop at normal speeds, the transmission shift fine between 1-2 gear, but when it goes to shift into third gear, there's a pause, almost like the brakes are applied. And so it talks about how to test for it. And the number one repair was to reprogram the transmission computer. 6 of them were replaced the engine computer. Only 6 of them replaced the automatic transmission. So you can see where there is, so something that sounds like a horrific problem with inside the transmission, turns out most commonly it's a relearn procedure. So I can come into test details and it walks me through it. Oh, look, a lab scope pattern. So it talks about how to test it and then come in and look at it. Also refer to any technical service bulletins. And here's all the people that have posted what the complaint was and what they did. So this doesn't mean this is what's wrong with my car, but it does give me some statistics on where I should test first. Okay, so this isn't about what part I replace. Unfortunately, some people use it that way. It's really about, what's the most likely cause. So I can also put a code in here. And let's see, does this come up at all? If not, then this car doesn't have that problem. Oh, crankspout won't start. So this has a remote start system problem. Oh, here we have an issue with two codes, but it looks like the little trigger wheel is damaged, not the crankshaft. I mean, not the sensor. So you can see we're just putting a sensor in from a code would not fix the car. A lot of times these people have already put a sensor in, as you read. Like here, the cam and crankshaft sensors have been replaced, but the problem is the same. So someone's already loaded both barrels of the part shotgun and hasn't fixed the car. That's why they're here. So you can see where, again, going down through. So this can be really helpful, especially when you're dealing with a problem that you've never dealt with before. You only have so much time to diagnose something. I'm looking for a direction sometimes, and sometimes this can provide a direction. So this is just another resource. And they do have some wiring diagrams and specifications and repair manuals and factory wiring diagrams and service manuals and other things available in here, TSBs. So there's a whole bunch of other information in here. So like all of these resources, because they're online, they're pretty in-depth and allows a technician to find things. If you're going to a shop, they should have access to this stuff. If they don't have access to these things and they're still using paper invoices and not using computers, then they're probably not going to be able to fix your car efficiently, because now you're paying for them to learn what I can go online and find out very quickly. Which means your car's going to be there longer, probably going to get parts it doesn't need and not be repaired correctly. So this is a big deal. Any questions on these systems? I do see I have something in chat. My chat was covered up a little bit. Lockout, tag out. Oh, there is a fleet term right there. In other words, when you're working on something and it's not supposed to be moved, it is locked and tagged, so no one touches it. Normally in the automotive, in the shop, no one's allowed to touch a car in your bay. Once it's in your bay, no one else touches it. So it's automatically locked out and tagged out just by being in your work area. And that's something that in professional shops, that's kind of how we deal with that same issue, where if you're dealing in a fleet service, especially when you have different shifts and there's not always communication, you have procedures where things are locked and tagged. Generally, the only things we tag are something like no brakes or batteries disconnected for a reason, don't crank engine, or things like that, where we'll have catastrophic damage if someone comes in and tries to undo something we did. But if it's in my service bay, no one else, including the service writer, touches that vehicle without asking first. And that is just to prevent exactly what we're talking about. Going back to whether it's a lockout tag out as using tags, or whether it's just professional courtesy that you have in the auto shop among professionals. You just never touch someone else's tools. You never touch someone else's things that are in their workspace. You just don't do it because it creates issues very quickly with that. Any other questions on information systems?
I have a question.
Sure.
How much do these programs cost?
It's been a while since I bought ALLDATA for the shop, but I used to pay for my shop close to $200 a month.
Oh, wow.
It's free right now for students. I mean, I got it through my last class. I have ProDemand.
Right. Yeah, I do have an access for ProDemand. I don't use that. The school does have some access for ALLDATA also. And I don't, this is not the school's ALLDATA, this is mine, because I do writing and curriculum development. So the company I work for gives me ALLDATA. So I have a full version of that. I have a full version of Mitchell somewhere also. I just never use it. But yeah, I know that they were on hold. I know they just got access codes again from Mitchell. I usually don't assign any tasks where you're looking that stuff up. And I'm always happy to look up stuff for you guys. But I do have some stuff on Mitchell, so I will. They just gave a new thing, so I will put that out. And we also have these all on campus also, in the computer lab on campus. So when we're on campus, we have some access to that. Any other questions? But no, these systems are expensive, and that's why, you know, like I said, at the shop, we have all of these. You know, so the owner's probably paying with the number of licenses for them, takes 500, 600 bucks a month just for information systems. So that we can get the information to fix cars. I mean, it's a tool just like any other tool, it's just expensive. Okay, so vehicle identification number, or VIN, as we call it. So this is the single most important piece of information when it comes to IDing your vehicle. It's not the only piece of information we need, but it's the single most important. So therefore, we have a lab assignment on this. So the vehicle VIN, key piece of information needed to correctly identify the vehicle as being repaired. All vehicles from 1981 to present use a 17-digit VIN. So there's a lot of standardization in that 17-digit VIN. There's also some things that are different. Some of the information that can be obtained from the VIN is the model year, engine size, model or body style, manufacturing plant, and production number. So on the lab assignment for this, one of the questions I ask for is the manufacturing plant. The manufacturing plant is normally the name of a city. So in the past, people put like Toyota of North America. Toyota of North America is a manufacturer. It's not a manufacturing plant. Manufacturing plant might be Louisville, or it might be Tacoma. Those are manufacturing plants for Toyota. Toyota North America is not a manufacturing plant. It's just like for Mercedes. You know, Germany is not a manufacturing plant. Stuttgart is a manufacturing plant. And sometimes you'll see for Mercedes, it's actually manufactured in North Carolina. So why do I care about that? One, it's the 11th digit of the VIN. We should know that. The other is many times when we're looking at parts, something as simple as brake pads for some models of Toyota Camry, some years Toyota Camry, I need to know, is that vehicle made in Japan or is it made in Kentucky, in order to get the right brake pads? Because they're two different ones. Sometimes it comes down to the right spark plug. Where was the vehicle made? We talked about technical service bulletins. Sometimes there's a technical service bulletin that only applies to vehicles made at a certain manufacturing plant. Why? Because that's the plant that had the problem. Either the part that they got was defective or substandard, or maybe, you know, say I have a vehicle made in St. Louis, and it's the month that St. Louis is in the World Series and in the playoffs. Do you think that maybe the quality of the car might have had an issue while everyone is partying and celebrating for a month? Just saying, you know, and you kind of laugh about that, but it's true. You can actually see some of this stuff where they have problems, like when the city wins the Super Bowl, and then they have problems with like vehicles manufactured over this window when the team was in the playoffs and winning the Super Bowl. So it does actually affect quality, strangely enough. You will see some of these, and you look at some of these real narrow dates, it's like, wait a minute, what was going on there? Other times it's simply a supply chain issue where the raw materials or the components furnished to one plant or a group of plants are different than the component service to another plant, because they'll source things locally instead of shipping. And this is especially true for international. So you may see a problem where, you know, this part's only affected by vehicles made at these Japanese plants or by these North American plants or so on. So that is, it's not real common. So that is, so when you're looking at the VIN, I have a lab sheet for this. I don't want you just to copy the letters of the VIN and say, oh yeah, the manufacturing plant's a Y. No, a Y is the letter in the VIN. I want to know the name of the city. And so on the assignment page, I have a VIN decoder that's free. There's a link there you can click on and actually put your VIN in, decode it, and get me all the information. So this is a great way for you to learn more about your vehicle, and it's always kind of fun. So where am I going to find the VIN? Well, two places. One is either in front of the windshield or up on the A pillar here, somewhere around in here. The other place I will find it is over by the B pillar on the back of the door where it goes on to the B pillar. I'll show you coming up. So this is where our VIN tag is going to be. And I can also see it here on the B pillar. And so then I'm decoding the VIN. So the first couple of digits are standard. So the first is always the country of origin. The next is the manufacturer, and then vehicle type, body type. Once we get to the 5th to the 8th digits, they vary by manufacturer. So Asian vehicles, the 5th digit is normally the engine size. Domestic manufacturers, the 8th digit is the engine size. So this is going to change based on what continent, because the manufacturers are allowed to play with that 5th through 8th digit. They can kind of do what they want with them. So in this case, Subaru, you have the series, the restraint type, restraint being airbags. What kind of airbag system does it have? And the model. So that is your 5th through 8th digit. So these are going to be very different on a domestic vehicle than they are on an Asian vehicle. 7th is my check type. And what the check digit does is it tells the computer that this R is, ours, I'm going to have to do the math on that. R's a hard digit. So we go from A to Z basically, and then 1 to 9 or 0 to 9 every 30 years. And so what the check digit does is tells the difference between an 81 and a 2011. Because although you and I could probably look at a car and tell if it's an 81 or a 2011, the computer can't. So that check digit qualifies the 10th digit, which is the model year, is an 86 or a 2016, because it's repeating every 30, what is it? Yeah, 30 years, 40 years, 40 years, I guess. No, 30 years. And then we have the plant, which is digit 11. That's the manufacturing plant. And then the actual serial number. Serial number is the production number of what in series. So if you have a 000001, that's the first of that series that rolled off the assembly line with all those other numbers. So that'd be the first one that year that came off the assembly line on that series. So this is where it counts up. So many times when we look at technical service bulletins or recalls, it'll be only up to a certain serial number or between certain serial numbers. Many times for parts, when we look up parts at the dealership, we're only looking at the last 8 or 9 digits is all the parts department needs. So we got 6 here, 7, 8, or 9. So it really depends on that. So somewhere over the last 9, which is domestics, which includes the engine size, or they just want the last 8, or other manufacturers, especially Asian manufacturers, want the entire 17-digit VIN to get the right part. So it kind of depends a little bit on manufacturer. So here's an example of a weight sticker. This also has the VIN on it. So here I can see where the vehicle is made, in this case, Kentucky, and it was manufactured 2 of 12. Now, this vehicle happens to be a 2012, but the manufacture date does not make it a 2012. So the days of, gee, if it was made before August, it's this year. If it's made after August, it's this year, have been gone since the 1960s. So that's something that's kind of held over. Volvo made 1998 Volvos in 1996. Subaru's made stuff a full year before the model year came out. So in the old days, they used to shut down every summer, retool, and you'd see body changes. So every year car looked different. I mean, so if I'm looking at a 55, a 56, and a 57 Chevy, which are all the same series, they look very different. And there's some significant differences in them. With modern vehicles, it's very slight differences year to year. And they run a body style much longer. So they're not shutting down to do that retooling the way they used to. The other thing is sometimes a manufacturer, if they come out with something really new, the brand new, whatever, 2024, they may release it in January of 23. And they may not make a 23. They may make 22s. Continue that through. Maybe we're going to make 2022s late. We'll make them into November. We're going to shut down for 3 or 4 months. And then we're going to come out with a brand new 2024 in February. Because when you know what, our brand new car is the first 2024 on the market. That's what people are going to want. So there's a lot of that marketing now that goes into model year that is completely independent of the manufacturer date. So manufacturer dates are very useful for cuts. So sometimes on parts, I need to know was the car made before or after a certain month or a certain year. So we do need that information to correctly identify things sometimes, but we should never be using the manufacturer date to determine vehicle year. We should be using the VIN for that and the underhood emission label or vehicle emission control system label, that key label. And those are the two places we're going to figure out what year the vehicle is. VIN is really the first source, and then that's backed up by the underhood emission label. The manufacturer date we should not be using to decide what year the vehicle is because it's not accurate. Our gross vehicle weight rating, this is the total weight that this vehicle is designed to carry. That's with all the fluids, gas in the tank, all the passengers, all the luggage, everything. This is the maximum capacity of the vehicle. That capacity is broken down into the front capacity and the rear capacity. And if you notice, if I add the front and rear together, it's more than the total. And that's normal because there's the total that can handle, but I can slide weight one way or the other. We're still dispersing that weight on the other side, and it's part of what the total vehicle can handle. So what are some of the things that limit the vehicle's ability to handle weight? One is tires. We get past tires, we look at bearings because the entire weight of the vehicle is on the axle bearings or wheel bearings. So if the bearings can't handle the weight, so they're really the extreme limiting factor. One limiting factor that's never thought about is brakes. How heavy can this vehicle be and still stop safely? And that's probably the most overlooked limiting factor on a vehicle. Hey, it'll hold it. See, it doesn't look like it sits that bad. It's still kind of level. Hey, it has a big engine. It'll be fine with that extra weight. All right, I got a V8. I can handle the weight. Yeah, but the car don't stop. And it's always disconcerting when you're driving a car and it flat out doesn't stop. So this tells you also that its vehicle conforms to all applicable federal motor vehicle safety, bumper, and theft prevention standards in effect on the date of manufacture. It's a passenger car, and then it has some other information down here and tells me it's made in USA. And this is going to be internal information that the dealer would have access to. This isn't something we're using on the aftermarket unless the dealer parts department asked us specifically for it. Here's another production weight. This one's 7 of 87. We have our manufacturing date, our gross vehicle weight rating. Then we have our front and rear. And then I also have my tire info. In this case, it gives me my tire size, my wheel size, and tire pressure. Again, we have our VIN number. It's a truck. And then we have quite a bit of other information under here that's used by Ford in this case. Give me the wheelbase, what transmission it has, body, trim type, and so on. So there's a sheet in there. So there's 3 lab sheets. One is going to be on the VIN. One is on our safety and weight label, which is this label here. And the next one is going to be on our ECS or VECI, vehicle emission control label. And so I have notes in the PowerPoint for each of these. So what I'm talking about now, if you didn't quite get it, or you're not sure, or you don't remember it when you go to do the lab sheet, there's notes in the PowerPoint that's on Canvas going through and explaining. That's also why I did the call outs on here, so you can see these things. So this is a VECI label or ECS label. The name changed somewhat recently, and I keep forgetting to update the PowerPoint. Old dog, new trick, that kind of stuff. We called them an ECS label forever. But these are a VECI label. So these can be broken down into several pieces. So the first thing I'm going to call out is the certification. So here you can see this vehicle conforms to US EPA and California regulations applicable to the 1987 model year. New heavy duty engines introduced into commerce solely for sale in California. So it has a heavy duty engine in it. only can be sold in California. So this is a California vehicle. So even though it conforms to US EPA and California regulations, if it conforms to both, it's a California vehicle. So we have the federal regulations here. California regulations for emissions are actually higher than the federal regulations. And that's because of an exemption that the Air Resource Board was able to get for California back in the 60s, and that continued up till 2017, 2018. So when we look at this, so this is not a federal and California vehicle, this is a California vehicle. So that's one of the questions I'll be asking. I can also see where it lists the engine size, in this case, 7.5 liter. And then it shows me my major emission equipment, in this case, EGR and AIP. If I don't know what those are, I showed you the acronym list and the resources in module 1, where you can look those up. I'll tell you that EGR is just that, exhaust gas recirculation, EGR. AIP is air injection pump. You'll also notice this vehicle does not have a catalytic converter. It says non-catalyst. And it's going to give me some service information. So in this case, it tells me how to check the ignition timing, adjust the fast idle, adjust the throttle kicker, adjust the curb idle. Also gives me a spark plug part number and spark plug gap. So it gives me quite a bit of information on this label. So this is a fairly old label, right? This is what, 1987 vehicle. This thing is now what, 34 years old, almost 35 years old. So fairly old vehicle, old label. They're still out there. Let's look at something a little bit newer. So this happens to be a 2000. So if we look here, this engine conforms to US EPA regulations applicable to the 2000 model year new heavy duty engines and is certified use in all heavy duty vehicles. So if you notice, when we're in heavy duty, we certify the engine. When we're in light duty, we certify the vehicle. And the difference between light duty and heavy duty is 8,500 pounds gross vehicle weight rating. So 8,500 pounds and less is light duty, 8,501 and more is heavy duty when it comes to emission certification. So here I can see the engine size, 5.7 liters. We notice this is not a California vehicle because California is not mentioned anywhere. This vehicle is heavy duty. We also have what's called our engine family or test group. So depending on the manufacturer, you'll see it listed as engine family, or you may see it as test group. So this is one of the things you're going to have to get off the label and put on the lab sheet. The engine family will have the engine size in it normally. So here I have a YGM XH 05.7 582. So the Y is for the model year 2000. That's going to match the 10th digit on the VIN. GM is the manufacturer. The XH, I can't remember what the XJ is. We don't use it, so I never remember it. The 05.7 is the engine size. The 582 is the emission certification. So we have a lot of different levels of emission certification. So it could be a low emission vehicle, an ultra low emission vehicle, a super ultra low emission vehicle. Then there's generation 1, generation 2, a partial zero emission vehicle. All these different things are different emission certifications. That's what that last 3 digits designates, is the emission certification. Here I have maintenance stuff. I have the spark plug gap, and it tells me that the engine spark timing and idle speeds are automatically controlled. Do not attempt adjustment. See service and maintenance schedule for more information. Perfect. Here is my emission control systems. Here I have a catalyst. I also have SEFI, which if I go to the chart in the acronym stands for sequential fuel injection. EGR, exhaust gas recirculation. HO2S, heated O2 sensor. And TWC is 3-way converter. That's the type of converter it has. So there's my major emission control components. The vehicle will have other emission controls on it. These are the major components that are listed. The vehicle also has what's called fuel evaporation. It's not listed because every vehicle has to have it, so we no longer list it. Also, what's important to note is this is not an OBD2 vehicle. So if you were under the impression that all vehicles 96 and newer are OBD2, you are wrong. Not all vehicles 96 and newer are OBD2. All light duty vehicles 96 and newer are OBD2, but federal medium duty vehicles such as this didn't have to be OBD2 until 2007. And if a vehicle weighs over 14,000 pounds, it's still not OBD2 because the OBD2 regulations only go to 14,000 pounds. And also that little connector that's underneath the dash that has 16 pins in it, that's a 16-pin diagnostic link connector. It is not an OBD2 connector. There are plenty of vehicles that have that connector that are not OBD2. So that's another kind of naming thing that's been used. It's called an OBD2 connector. It's not. It's a 16-pin diagnostic link connector that may or may not be connected to an OBD2 computer. And when we get into computers, we'll talk about actually what makes an OBD2 computer. So here is another vehicle. So this engine, first clue, heavy duty, conforms to US EPA regulations applicable to the 2002 model year, ULEV, ultra low emission vehicle, heavy duty gasoline fueled engine, and meets all appropriate requirements for 40 CFR Part 88, which is just a federal regulation. This engine conforms to California regulations applicable to 2002 model year new heavy duty auto cycle engines and to US EPA regulations applicable to California. This engine is certified for use only in heavy duty vehicles with a gross vehicle weight rating above 14,000 pounds. And it is OBD1 certified. So here's another example. This has to be a California vehicle because it meets California and federal standards. So it's a California vehicle. 2002, it is not OBD2 certified. In this case, it is OBD1 certified because it's a California vehicle. So again, going back to not everything 96 and newer is OBD2. We talk about tune-up information up top and say that the engine idle speed, idle mixture, and ignition timing are not adjustable. And then we give the spark plug gap right here. It gives me my engine size, 6.8 liters. And then I have two long numbers. One of them is this 2FMXE0155BAJ, and the other one is 2FMXH06.8 CH5. This is the engine family or test group because it has the engine size in it. This is the evaporative family because it does not have the engine size in it. So on a modern sticker, we're going to see both of those numbers. We're going to see both numbers, both start out the same. They're going to have the year. They're going to have the manufacturer. One of them is going to have the engine size in it. One is not. As we can see, the engine size is 6.8 liters. And what do I have here? 6.8. And then I have 3 digits after that for the emission group. This does not have the engine size in it. That tells me this is the fuel evaporation family, and this is the engine family or test group or engine test group because it has the engine size in it. I can't stress this strong enough because every time I teach this class, about half of the assignments have the wrong engine family listed and it gets kicked back. So I'm really trying to spend some time on that this time. Then I have my major emission controls, my 3-way cat, 2 heated oxygen sensors. So that's what the 2 in front means. There's 2 of them on this vehicle, and SFI, sequential fuel injection. So that's my major emission control components. We look at another one. Here's a Lexus. So here's my engine family or test group. So again, BMW might call it a test group. Where Toyota calls it an engine family. It means the same thing. A lot of stuff in auto, we have more than one name for things. So here's my test group again. Y for the year, TY Toyota. I have the 3.0 and then 3 things after it, letters or numbers. My EVAP family does not have the engine size in it. So that's the easiest way to tell the difference. Here it's a 3-liter engine. My control equipment is Cepheid, 2 AFS, 2 air fuel ratio sensors. Again, it's in the acronym list. By the end of the class, you'll know all of these. 2 warm-up 3-way catalytic converters, another regular cat three-way catalytic converter, and a heated O2 sensor. So it lists all the stuff. And that's why I put those acronym pages up in the resources for you in module 1, because you can see there's a lot of alphabet soup here, and we're just scratching the surface. Engine tune-up specifications. Here just gives me a valve adjustment, and no other adjustments are needed. This vehicle, see, now we're talking about a vehicle, no longer about an engine. This vehicle conforms to US EPA NLEV regulations, new low emission vehicle regulations applicable to gasoline fuel 2000 model year, new LEV, low emission vehicle passenger cars, and to California regulations applicable to 2000 model year, new LEV passenger cars. I get the impression that this is a LEV passenger car for California. And they kind of said it a couple times here. So this is not a federal vehicle. This is a California vehicle. It does tell me it's OBD2 certified. It does tell me it has catalytic converter, and this vehicle is made for both the US and Canada. So here's our engine family right there. So these are our old style labels. Now we have the new style labels, which look like this. We went to these in about 2007, 2008 is when we changed over to these. And so here, US EPA Tier 2 Bin 5 light duty truck, LDT, OBD2 certified for diesel. And also it's a California LEV, LEV2, excuse me, light duty truck, OBD2 certified, powered by diesel. Then it lists all my emission controls. So direct injection, 2 turbochargers, a charge air cooler, which is an intercooler, an EGR valve, selective catalyst reduction, which is a converter that's designed to reduce NOx emissions, diesel particulate filter, which is a filter in the exhaust to get rid of smoke, oxidation catalyst, NOx sensors ×2, and an air fuel ratio sensor. So you can see why I put those acronym pages in. And here's my group, or we're calling a group, but what do we have? B, okay, that's the year. That's going to be the first, that's going to be the 10th digit of the VIN. BM for BMW. The XT, I don't worry about that. We got what? 3.0, 03.0. Hey, that's the engine size. And then M57, which is the emission certification. So that's my engine family there. So even though they're calling it a group, that's the engine family. Here is a federal label on the new label. And you can see on a federal label, California just says NA, or California will be blank. So this vehicle was not certified for sale in California. It can only be sold in states that do not use California emissions standards. That being said, this car can still be brought into California after it has more than 7,500 miles on it. Once a vehicle has more than 7,500 miles on it, it is no longer considered a new vehicle. So we do have vehicles in California that do not meet California emission standards at time of production, but they are legal to be here. So those are our federal vehicles, but they can only be brought here after they have more than 7,500 miles, with a couple of exceptions. So if someone is active duty military and transferred here, they can be brought in. If you were out of state, you got in a wreck, or your car engine blew up or whatever, and you had to replace that vehicle to get back to California, you can replace it with a non-California vehicle. Or if you've just moved here from out of state, you can also bring it in. But if you're living here, I can't go buy a vehicle out of state that's not California certified. So sometimes you'll see certain performance packages or certain engine options that are not available for sale in California. We cannot bring those vehicles in when they're new. We can bring those vehicles in when they're used over 7,500 miles. So that's the loophole. And I actually went through that when I brought my Harley in. I brought my Harley in, and it was a federal vehicle. And this was back in 2005, and I didn't have enough miles on it. And so when we were doing the check, I didn't know it applied to motorcycles. And fortunately, I went to a DMV service I knew instead of going to DMV. And they said, "Oh, you need to put some more miles on this. You can't bring it in yet." I said, "Oh, shoot. I didn't know that they were doing that on bikes." They said, "Yeah." And so I had to put like another 3,000 miles on my bike so I could register it in California in the next month and a half. So I did a lot of riding. See, over 7,500 miles, I can bring it in now. Because the issue is if you bring it in, try to bring it in before then, the VIN gets blackballed. You get 30 days to remove it from the state. And you can't ever register it here.
Is it 7,500 miles across the board or just for that manufacturer or for that label?
No, 7,500 miles if the vehicle is not certified to California standards. But if I go to Reno and buy a car that has California standards on it, I can bring it in with 100 miles on it. That's not a problem. It's only if it doesn't meet California emissions. Because like I have a friend of mine who's up in Mammoth. He's a smog tech up there. Most of the smogs he does are on cars that people buy in Reno and bring into Mammoth because they can get a better price in Reno than they can in Bishop or Sacramento. So they actually go to Reno to buy them instead of going somewhere else. But they make sure they buy California certified vehicles because if they don't, then they can't bring them in. So it's all a matter of knowing what the rules are so you can play, right? I mean, that's the whole thing. Just let me know where the wiggle room is. Let me know where the loopholes are, and then I'll figure it out. So this has our engine displacement, our model year, my test group. And this one gets a little confusing because they use group here, but they use family here. This has 2.3 in it. This does not. This is the engine family. This is the EVAP family. And then here, it gives me the different emission controls. In this case, three-way catalytic converter, heated oxygen sensor, heated air fuel sensor, EGR, and sequential fuel injection. So it lists out my emission controls. So we can see where this is going to be listed out. And this is something, I know a lot of this, I'm speaking Greek to you right now. Don't worry about it. I don't expect anyone to remember all those emission controls today. That's why we have the sheets in there. But these are the terms by the end of class you will know. Because this is the language we speak. And we're also going to know what each of these systems are because we're going to learn about every one of them in class. So here is a diesel. In this case, this engine conforms to California regulations, applicable to the 2008 model year ULEV, ultra low emission vehicle, medium duty engines, complete vehicle, gross vehicle weight rating of 8,501 to 14,000 pounds. Then a maximal frontal area of 45 square feet. So the interesting, once we get above 8,500 pounds, the engines are certified, and we see this going up even over 14,000 pounds. And this allows chassis builders to buy power plants from GM and build their own truck around them. And so we see this a lot where these power plants are used to other places, not just in that manufacturer's. And so that's why you kind of get in this. Also, you talk about 45 square foot frontal area. That means this engine probably isn't appropriate for a Class A motorhome where you have a big bread box going down the road, because that's more than 45 square feet of frontal area, isn't it? Right. So so you can see where, how these engines can be used is very different. So it does list all of our emission controls. And it does list our displacement. Our engine family is over here, and it's kind of hard to see, but again, it has the 6.6 in here. You'll be able to read it. But this is just off of medium duty that I pulled. So if the label is missing, we would use what's called an ECS manual, or emission control system manual. And so these manuals allow us to look up year, make, model, engine size, and see what emission controls are required. And they also have footnotes. So the example I have here is for a 99 F-Series pickup truck with a 7.3 liter diesel engine. And this truck had positive crankcase ventilation, PCV, had an oxidation catalyst with a footnote, computerized engine controls, and a malfunction indicator light. A malfunction indicator light is what you call a check engine light. The real thing it's called is a malfunction indicator light. So here for the oxidation converter, it only applies if the vehicle is manufactured before 12/8 of 98. So where am I going to get that information? I'm going to get that information off that sticker on the door, aren't I? Right? So you see where these kind of come in, where you really need to know these different pieces to really figure out how they all fit together and get the right information. So if this vehicle is in for smog and it doesn't have a catalytic converter, and for some reason that sticker is missing from the door jamb, I'm going to fail the vehicle. Because I can't prove it was manufactured, not manufactured before 12/8 of 98, because the sticker's missing. So one of the things that's not understood, because of the smog and because of the professional license, then every car fails until it proves it passes, because until it proves it's correct, I can't assume it is correct. And I see the question about the XH is a family type. Is that a question, or was that an observation, or?
No, Mr. Brian, I looked it up. That number you couldn't, or the two letters you couldn't remember. I looked it up. It was family type.
Okay. Yeah, because they have XH, XJ. There's a couple different ones.
Yeah, they're all family types. Like the one that I saw for this was like a non-road something. It was like a
Okay.
tractor.
Yeah, so like I said, I knew the X something was, they're all X and like a J or an H or different thing. And we don't use them, so I can't remember what they are. And I
Yeah.
know I looked them up a couple times and it just hasn't stuck in the gray matter.
Yeah.
I tend to remember things that make me money, and the things that don't make me money, I tend to forget. So that's the occupational hazard, I guess. So, and with that being said, there's a lot of random stuff floating around in here. So any questions on these labels that you're going to be doing the lab on? Like I said, I do have good notes on the PowerPoint. I do read every one of these when they're turned in. And then, depending on what I see, I may give full credit and just send a note back, or I may give partial credit and send a note back saying, here's what you need to fix to get full credit, or so on. Preston, did you see the note that I sent you back on the one you turned in? You're muted, or I'm not hearing you.
Oh, yeah, sorry about that. Yeah, I saw the note. I didn't see that in the pamphlet. That's why I decided to create a whole new work order.
Right.
And I didn't catch that one.
Yeah, not a problem. And like I said, you had the body of the answer was correct. And that's why I gave you the full credit on it. But I wanted to clarify the point. So a lot of times when I have you guys type in things or input in things, I'm not looking for a parrot back, because I know I'm going to get potentially 10 or 20 different answers because they're in your own words. I'm looking at, do you get the intent? What's the most important thing? You don't put the parts on before you talk to the customer. You make sure you get an estimate, and you had all of that. The only difference was, hey, can we revise this work order or get a new one? And again, that's experience in trying to read through a document. And that's why I clarified it. So that way, going forward, but it doesn't affect the grade, because you learned what I wanted you to learn from the assignment. So that kind of gives you a view into kind of how I grade these. And yeah, Jessica, you got a question.
If you can go back a slide or two, on one of the labels, yeah, go back. And that's a go back. No, forward two.
This
Next
one or one more?
One more.
The diesel one, okay?
Right. So it says 350 at 3,000.
Right,
is that?
for the horsepower, right.
So can you explain it to me?
Okay, so once we get into, especially we see this on diesels, they actually rate the horsepower and torque at a specified RPM. So it's a little counterintuitive, because you actually have higher horsepower diesels in smaller vehicles. And when we get in engines, I'll explain a little bit more about why that is. But so if I put this engine, because this happens to be a GM, this is a Duramax. So they use the Duramax in things, everything from like a 2,500 pickup truck up to a 2-ton truck. I mean, they use them in quite a few different ranges. So they don't all have the same horsepower and torque. So in the case of Ford 6-liters that I'm pretty familiar with, they made 5 different models of horsepower and torque of that Ford 6-liter, depending on what it was put into. Because as we increase the weight, I need the torque. I don't necessarily want the horsepower, because that's when things break. So because horsepower is how fast I'm moving, where torque is the ability to turn or the ability to rotate. And so I want a lot of the ability to rotate because I got a lot of weight I got to move. I don't necessarily want to do it quickly because if I do it too quickly, that's when things get unhappy and they break. So they actually, you'll see as we move up in bigger trucks, they have less horsepower, but they have huge torque. As we move down in trucks to like a 2500, I've got more horsepower because I'm moving a lighter vehicle quicker, but we'll actually cut the torque down a little bit because we want that horsepower. So in this case, they're showing for this engine, it's rated at 350 brake horsepower. BHP is brake horsepower at 3000 RPM. And the torque is 650 foot-pounds of torque at 2000 RPM. And this is also very common because torque peaks before horsepower peaks. And that's why as you're revving the engine up, you're nowhere near red line when you're shifting to your next gear. Why? Because you're in that sweet spot of torque. You're not trying to rev the engine all the way up where you've lost torque, but you're trying to get horsepower because you're trying to move a large load. And you know that from towing, right? You're not running that sucker up to red. You're hitting that sweet spot for torque and going through the gears because that's where you're most efficient. And when you have a lot of weight, and at the same time, that truck probably drives a little bit different on the way back than it does on the way out when it's full of Coca-Cola, because Coca-Cola is heavy. So again, that's also going to affect how you shift and your shift points because you're running with an empty load versus a full load. So that's the why. But no, great questions. The amazing thing is I actually know it. But no, it is true. So if I'm driving a Honda, I'm going to wind that sucker out almost to red line before I shift gears. If I'm driving my F-250 and I got a full trailer on it, I'm shifting right around maximum torque. I'm not running that sucker out, which makes the people behind you upset because they're in a hurry. They're driving a small car. No, I'm trying to keep this thing going because I've got way lots of weight here. So yeah, it's all about management. Great question. Okay, let's see. So let me jump a little bit here. I'm going to hit a little bit on safety. So safety can be brought to death. Keep in mind, I want everyone to be safe. I want safe practices. What do they say? It's all fun until someone gets hurt. Isn't that what my mom used to tell me? Yeah, it's all fun and games until someone gets hurt. Or you cut someone's finger off or whatever it is, right?
Yeah, loses an eye.
Yeah, it was always fun until someone had to go to the ER, you know? When I knew I was in trouble was when someone was going to the ER. And we did a lot of things you probably just shouldn't have been doing. But that was, you know, part of being kids. So shop safety is everyone's responsibility. So we do need to take it seriously. At the same time, I don't believe we all need to be wrapped in bubble wrap. And I don't like safety rules because we want to scare you to death and we have safety rules. So instead of teaching you how things work, we're just going to scare you to death so you're always safe. I think that's a bad way of being safe. So everything we do, there's risk. Everything we do, we can get hurt doing. Many things we do, we've been hurt doing before. That's how we learn not to do it that way. Don't put your finger here, it gets pinched. What do you mean? Ouch. Okay, now I know what you mean, right? So, I mean, we've all done those things, whether it's using a knife or even using a fork, right? We've probably at some time in our lives stabbed ourselves with a fork and learned not to do that. But yet we're all allowed to use a fork, hopefully. So that, you know, the same thing is true with safety. So we need to take it seriously. We need to be observant. We need to follow good practices. But especially when we get into hybrid and we get into some of these other technologies, I am not a fan of scaring people to death. And I think that comes from being in the industry for a long time and being in the 1980s when ABS brake systems first came out. And they scared us with ABS. People were literally scared to work on cars with ABS brakes. There are stories about people having their arms amputated because of ABS brakes because they take an accumulator off and brake fluid be injected into it and they couldn't get the fluid out. So they had to amputate the arm. And we had all kinds of stories about how you need to be super careful of these things. I went to a lot of training. I still have some of those training books and they were really about scare you to be safe. We don't have those discussions anymore because everyone's comfortable with the technology and we know how ABS brakes work. I saw the same thing when it came to airbags, and we started putting airbags in cars. And I knew people that wouldn't work on cars with airbags, and they're going to explode in your face, and they're going to hurt you, and all these other things. And we really don't think twice about them today because they've been around now for over 30 years, and we're very comfortable with them. The new thing we're scaring everyone with is hybrid and electric vehicles. That's the new thing that's going to kill you. If you even look at a hybrid vehicle crosswise, the lightning bolt will jump out and electrocute you. And somehow terrifying people makes them safe. And I don't buy into that. I buy into, if you know how something works, then you know how to be safe around it. Going back to my fork analogy, there's a reason why you don't give a 1-year-old a fork, because they're going to poke themselves in the face. Okay. That's why they get a spoon. Hopefully by the time you're 20 or 30, you're allowed to use a fork. So the same thing is true here. That the idea is know what the tool is, know how to use it. So, every year technicians are hurt. Broken safety rules, missing eye protection, loose fitting or improper clothes, loose or long hair, or not contained. I've had metal drilled out of my eyes. I am not a safety glass guy. I didn't wear safety glass for a long time. I wear glasses now because I need them to see. Not to say I would never wear safety glasses. And actually the metal I had to have drilled out of my eye was after I took my safety glasses off, and it fell out of my hair and into my eye. I've had stuff bounce off my forehead into the safety glasses and into my eye. So, I mean, it will find a way. I've had brake springs come off in my eye. I thought I lost my eye once. That one hurt like hell. I mean, I've had things. So, I mean, there is definitely a reason to be safe. And I've had a lot of metal taken out of my eyes and washed. I got pretty good at getting metal out of my eyes. And so some of that's occupational hazard. Some of it's you're laying underneath a rusty vehicle and you get covered in rust because something moves, and stuff's gonna, so you learn to close your eyes and try to dust yourself off and take your, before you even open your eyes up. And even then you still get stuff in your eyes sometimes. Things happen. So the question is, what do I do when things happen? Where's the eye wash station? How do I wash it out? What do I do? What don't I do? Those types of things. I know I've personally had my fingers get hit by alternator fans. Fortunately, going the way it didn't cut them, it just bounced them off. I had a student, not a full-time student at ECC. I was teaching a private school during smog update training. So this was a professional technician, been doing it 20 years. He was doing a 4-night update class for his license. He came the first 2 nights. I didn't see him the next week. Like, what happened to him? Found out. Reason why he missed the second week and the last 2 nights is because, he was missing a couple fingers now. Because he was checking timing, something he had done numerous times. And then he kind of worked late past lunchtime, trying to get another job done. Got too close to a fan belt, serpentine belt on a Jeep, checking the timing, and it pulled his fingers through the belt, between the belt and the pulley. He's probably checked the timing on over 1,000 vehicles. It's not like he didn't know how to check timing. What was he doing? He was working on a hot day when he's past when he should have eaten, trying to hurry. And I don't know about you all, but when my blood sugar starts getting lower, I haven't eaten. You start getting the shakes. You don't think as good. You don't function as good. So part of being safety is just making good decisions. I learned that I just needed to stop and eat at noon. So when I went back after I sold my shop, and I actually learned this, and I made my employees do it. I learned I used to just shut down the shop at noon. Everyone eats lunch now. I don't care if you don't want to. Well, no, I like to work. No, we're doing this in a separate regimen. When I got rid of my shop, went back to working full time in a shop as a tech. 12 o'clock, I'm eating lunch, and I don't care what you promised the customer. I have a service driver. Well, I just took this car and they're waiting. Okay, well, they'll be waiting when I get done with lunch. I'm not worried about it. They'll still be waiting because I'm eating lunch. Car don't go without gas, and this car needs gas. So we don't think about eating as safety, but it is. And getting a drink when it's hot and we're working and we're sweating and all that. And it's amazing. I can work in a shop on a hot day. I'm not sweating that much. I go and try to put a nut and bolt together in a dash or try to line something up, sweat's pouring off as I'm concentrating, trying to put something together. So, as our mind works harder, we sweat more. It's really kind of amazing, but our brain uses more energy than any other organ in our body. And when we're actually concentrating, we really work up a sweat. And one thing I learned is that where I just want to get this together before I go to lunch, and it'd take me like 20 minutes to get something together. And I'm, just sweat's pouring off and frustrating. What I learned is if it doesn't go together, stop. It's lunchtime. I come back, that thing goes together like that, piece of cake. And that was something that it took me a lot of years to learn. And that comes back to safety, because when you're, doing that, or you're rushed, or you're not willing to take that breath and step back, is when we get hurt. I had a technician I had known for 20 years when he was working for me. Last day, last job, he asked me, hey, would you like me to put the tires on that car for you? Sure, appreciate it. Cut his finger off on the tire machine, last day, last job. I had known this technician for 20 years. Walks in the office with a rag around his finger, says, I just cut my finger off. Okay, well, let's take you over to the emergency room, see if they can put it back on. And they did. They were able to reattach it. So there's my workers' comp rate. Guy cut a finger off. All right, obviously my fault. Nothing wrong with the machine. Turns out he was actually on some medication that he was not supposed to be working with equipment and didn't tell me. Swing and a miss. But no, his finger got all back together and all that. So, I mean, that's the important thing. But things do happen. It's not that he didn't know how to use the tire machine. It's that he was taking a medication that said you're not supposed to be using equipment, and figured he's okay and didn't tell me. So things do happen. And that's why it's important to think about safety. So I'd rather concentrate on those kinds of safety, because all the examples I gave you and the people I know that have had to go to the ER work aren't because it's the first time they did the job. It's because I've done the job 100 times or 1,000 times. And, hey, I got this. Hey, not paying attention. I know I'm much more likely to get hurt if I'm talking to someone when I'm working underneath the hood than if I'm working underneath the hood by myself, just listening to the radio. Right? I'm in my zone. If I'm getting distracted, I make mistakes. And obviously at school, because of the class environment, there's a lot more distraction. So we need to slow down and be safer. Always wear eye protection and face protection when working in a shop, period. Batteries, change the battery. Batteries explode. I've seen batteries explode. Battery acid, it will blind you. So, I mean, there's things that you just don't expect. So types of accidents, obviously fires. Well, I've had cars catch on fire. That's why there's fire extinguishers. Explosions, asphyxiation. There's a lot of airborne poisons. There's a lot of chemicals that we deal with in the automotive industry, some of which are deadly when burned. Chemical burns, specifically battery acid, electrical shock. I have a video in here where I get shocked multiple times by 30,000 volts. Yeah, Preston.
Do we need to bring our own iPro to class on Monday?
Own iPro?
Yeah, eye protection. Sorry.
Oh, eye protection.
Yeah, iPro. I call it iPro.
You're not going to need it at class on Monday because we're going to be using some trainers, so we're going to be good without eye protection.
Okay, but do
So
we need
yeah,
it
as we
eventually?
move forward, you will want to
Okay.
do that.
Roger that.
So it might be good to throw it in the car or whatever. Yeah, when we're doing batteries out in the shop, we're going to want to have eye protection. Great question. Slip and fall. So if you make a mess, clean it up right away. Don't leave it for later. Don't figure I'm going to get to it. Do a good job of cleaning it up. I had an incident at school. Some oil leaked out of a vehicle. The students had wiped it up, but they had not cleaned it up by using degreaser and making sure the oil had gotten out of the concrete. Then it sprinkled, and I'm walking through the auto complex. And even though I'm wearing my professional no slip shoes that I've worn forever, I hit that sucker, went down, and I went down hard on the concrete, and the head did the pop. And I was really sore for a couple of days. And I've been in a shop for close to 40 years now. I'm used to walking on slippery surfaces. Did not even see it. And there was water on top of that oil underneath, and the oil kind of come through a little bit. And boy, it might have been stepping on ice, just bad as black ice. It just went right out from underneath me and went down fast and hard. And it wasn't that they didn't wipe up the oil. Oh, there's oil, so let's just wipe it up. They didn't go get the mop bucket with the degreaser and clean the surface. Right? So they cut a corner. So when you cut a corner like that, what? Now you're putting someone else at risk. And so it's just important when we do clean up, we do a good job. So I have a little video here. See if this one plays here. So how many of you saw that coming? Right, just change the oil, having a little snack, BS, nice, nice relaxing day at work, and all of a sudden the car blows up. You saw the one person that left on the right side isn't the one that came back with the fire extinguisher on the left. So, I mean, kind of came up like disbelief, oh, it's on fire. Gee, what do we do now? That's also a good reason not to have your head underneath the hood when you start a car. That's why when we start a car, we yell clear so everyone is back from the car from underneath the hood when we turn the key. We had one explode like that in the shop, and it was with an aluminum intake manifold, and it exploded, that aluminum intake manifold. So that can happen. Who would have thought? I mean, changing oil is the safest thing in the world.
What
Until it's
happened?
not. What happened is someone had turned the key a couple times, most likely, probably to get mileage or to do other things. Every time you turn the key on a modern vehicle, the fuel injectors spray fuel. And they give it an initial spray before you crank the engine over, giving the fuel time to atomize so the vehicle will start more quickly. Well, if you've turned the key a couple times, you put a couple squirts of fuel into a hot engine. Now you have vaporized fuel in a contained area because the throttle plate is closed. So now if you get any kind of kickback at all out of that engine on startup, it'll actually ignite the air fuel mixture in the intake manifold. The gas expands, the throttle plate is keeping that expanding gas in the intake manifold, and the intake manifold explodes. So this case was a plastic intake manifold. They come apart pretty easy. Some early manifolds like Cadillac on the North Star actually had a valve that would blow open when this happened, so you didn't blow the manifold apart. The one we had was a Honda Odyssey with an aluminum intake manifold, and it actually opened the aluminum up like a tin can, a cast aluminum manifold. Pretty impressive. So, the power of thermal expansion is what makes your vehicle go down the road. So you can really see where, man, that's huge. And I like that video because it does really show you do need to pay attention. You do need to follow practices. If someone's starting a car, everyone around needs to know that car's starting. You shouldn't be starting a car when someone's hands or head are underneath the hood. Again, it's not designed to scare anyone. It's about let's have good practices and use common sense so we're all safe and we have fun and we learn. But that's why we do those things. I've had cars backfire. Back in the day of carburetors, cars backfired all the time. So I've burned all the hair off my arm. I used to have a beard, burned half my beard. I burned the hair up my nose. I mean, I've had plenty of fire explosions in the face over the years. You're doing this and you learn to reach back further. And it's amazing how far that flame can reach sometimes. But and that was very common on carbureted vehicles. So, things do happen. It's a matter of knowing how to deal with them and knowing how to, avoid being in the way of them when they do happen. Oops, wrong button. So lift points, we talk about lifting vehicles, and we'll go over this some on campus, but we have different lift points on each car. When we lift a vehicle, it should always be level. We should never go under a vehicle that is supported only by a jack. So we should be either using jack stands, or if we're using a lift, we should use the lift and put it on the safety stops. So when we put a vehicle up in the air, we always want the vehicle to be level. We don't want the front end to be higher than the back end or vice versa, because that can actually cause it to go one way or the other. We want to make sure that we have the vehicle in the correct position front to back. So when we look at our lift arms, there's two different kinds of lifts. There's a symmetrical and an asymmetrical. A symmetrical lift has two long arms, and you center the vehicle between them. An asymmetrical, which we have, has one arm that's bent. And you take that bent arm up till it's at a 90-degree angle or farther forward. You never rack a car with this back this way, because you're putting too much weight towards the back of the vehicle. So that front arm, which has that little bend in it, needs to be at 90 degrees to the post or farther forward. You can go further forward if you got a long vehicle. You cannot go further back. If you do, you put too much weight towards the back. And I've actually been in a shop. I came in right after it happened. These are only bolted in with 5.5-inch long red heads. And that works fine as long as the concrete's hard and you use it correctly. If the concrete's a little weak or it's not used correctly, I actually saw one where both of these posts pulled out of the ground with a truck on it. Thing went up, and then as it went into the truck, and everything kind of fell over on its side. A little ugly. So it is important. Also, as you put these up, you'll hear a clicking as it goes up, and then you lower it onto the stops before we go underneath the vehicle. I had at my shop, we had it was a 27,000-pound drive-on lift for doing trucks. My tech was putting a truck up, and the chain where it goes into the ram broke. The rear of the truck came down. It went right through all 4 safeties on the rear of this thing. And the safeties were like 5/8-inch thick steel and about 5 inches long. And it went through them like hot butter on its way down. There was nothing stopping that truck from hitting the ground. And that came down from about 5 feet up. It made a lot of noise. And fortunately, the tech was not underneath it. He was actually raising the vehicle at the time when it failed. But it gives you an idea of the safeties. The safeties are there to hold the vehicle. They're not there to stop it from falling. So don't expect too much out of them. These use hydraulics. If you have a hydraulic hose burst, things come down in a hurry. I know that because when my hose broke on my forklift here at the house, it came down in a hurry. So yeah, hydraulics, you have a leak, things happen very, very quickly. So we will talk about that, but I'm a real stickler on this. I'm fortunate. I have never had a vehicle come off a lift. I've had some close calls, but I've never had one come off a lift, either in a shop I managed or me personally. Again, had some close calls. One shop I worked at, the week before I started, they had and these racks were a little different. They were in ground. They had a forward post and a rear post, and you controlled them separately. They were a truck lift, and you bring them up and all that. Well, the controls were on the floor. And what guys used to do is let all the air out, go wash their hands, then they'd come back and lower the vehicle to save time. Well, what happened is the front valve wasn't closed all the way. So to let the air out, the front valve went down and the rear stayed up. And eventually the truck that was on it rolled onto the T-Bird that was parked next to it, while the owner of the T-Bird was in the waiting room and watched it happen. That's a bad day at the shop. That was the week before I got there. So yeah, that needs to say instant change of policy. Don't let the air out when you're not there. And these were hard because there were floor controls. People would kick them on the way by and things like that. I saw a couple almost incidents on those. Even when I was there, someone kicked a rear control and a truck went down and was resting on top of someone's toolbox. And the ram was all the way down. So we carefully got the ram back up and lifted it off the toolbox and brought the front down. And we were able to save it and the toolbox. But that's kind of nervous when you got a truck or a big, Cadillac or something big and things like that happen. So there was a friend of mine worked at a shop back in Minnesota where they did undercoating, and they had a 2-post in-ground lift with the arms that go in to connect the vehicle. And the guy put the car, and the people did back there is they'd buy the car and instantly go to get it undercoated. And he was working at Midas at the time who did undercoating. And so here's this car with 11 miles. It's in the bay on this lift up in the air to get this undercoating job for rust protection because they use salt on the road. We puts it up, it's all the way up, starts walking around, starts wiggling, all of a sudden the car falls. Boom, between the posts. One set of posts goes through, the arms go through the car. So now this car is on its side, impaled between 2 posts. They unbolted the post, trying to lower the post. The posts wouldn't go down. These are like the racks we have in the brake bays. The post would not go down. They ended up having to drag the car out on its side between the 2 posts. 11 miles, car's totaled. The tech did not rack the vehicle correctly. And so therefore the arms were out too far and it came out its end and dropped, and that's what caused the failure. It was technician error. So these are very, very safe as long as you follow practices. One of the things I see that drives me nuts is I'll have students use a lift and they put it on the lift and they raise it this far off the ground. And they're all working down here like they're working on the ground. And I'm like, what are you doing? The lift goes up all the way. Because they'll come over, hey, can you look at this? Yeah, first let's put this thing up in the air where we work on cars. Because there's a certain fear about having something that big up that high. And it takes a little bit of getting used to. I prefer a rack like this over working on floor jacks or jack stands or anything like that, because these are very, very secure, very, very safe. And when the safeties are working correctly, the arms can't move. Nothing's moving. As long as you're on the pads and as long as it's secure, that's not going anyway. I've been under these when there's an earthquake and things. I mean, the car's not going anywhere. There's really nowhere for it to go. So again, very complacent, has to do with the vehicle needs to be level. If you start putting it up and the vehicle does this, put it back down, reset. There's spacers that go in here that you can adjust to get that vehicle level when you pick it up. A level vehicle is a safe vehicle. So again, simple practices make it real safe. Keep fingers clear of moving parts. Oh, that's a good point. This is open inside here. And occasionally a safety lock won't want to release, or there might be something hung up because there's a cable that goes across. They had a student years ago before I started ECC decide not to come get faculty to help them and put their hand in there to a release. It only cost them 1 finger. So the lesson there is when things don't work, come get someone with more experience. Double check lift point. So when we raise the vehicle up, we raise it about 1 inch and shake the vehicle. If something's going to fall, I want it to fall when it's 1 inch off the ground, not 6 feet off the ground. And I shake them really good. Verify lift safety catch is engaged and do not walk under it until it's there. So hybrid safety. One day I was at campus and not my student. They were in I think they were in brakes and suspension class. Had their hybrid vehicle out there with soap and water, scrubbing their bright orange cables to make them nice and shiny. Bright orange means it has over 60 volts. Okay. Normally, most of these systems have anywhere from 200 to 600 volts. It's enough to kill you. Scrubbing them to make them nice, pretty, and orange is probably not the best use of your lab time. And what's more, lab time may end early doing that for everybody. So hybrid vehicles use a high voltage motor generator and battery pack. Generally from 142 up to 600 volts. We are seeing some new systems hit the 800 volt range on the full electrics. And we do have some belt operated hybrid systems that work down as low as 48 volts. So we do have a pretty big range here. Hybrid's kind of a all-encompassing term. Always follow manufacturer instructions and safety rules. Why do I say that? Because you should always follow manufacturer's procedures until you know better, right? So if I'm not familiar with something, I'm going to follow what the manufacturer says. If I've done it 30 times and really realize that step 1 and 8 are dumb, then maybe I won't do steps 1 and 8. But I need to, keep in mind that the instructions are written with lawyer repellent. So the manufacturers really are emphasized on being safe. So if you're not familiar with something, do that. Also, anytime there's a test question and the answer is follow my manufacturer's procedures, that's always the right answer. I don't ask that question, but I see them asked a lot. Wear rubber electrician's gloves if recommended by the vehicle manufacturer. Use insulated tools when appropriate. Disconnect or disable batteries during service. Professional technicians are killed and injured every year by working on high voltage systems. So these systems, unlike our 12-volt system, one mistake and it can be all over. So for 30 to 60 volts, manufacturers are required to use a blue wire, although they are allowed to use orange. Over 60 volts, they have to use orange. The smaller orange cables still have high voltage, just lower amperage. So as we can see here, this has 3 cables in this one harness, and it connects here. But you see this bright orange is telling us, hey, be careful of that. Well, this is pretty big and intimidating, right? But what about the bright orange over here? Should I be worried about that? Yeah, it's the same high voltage. So, this little wire can kill me just as easy as this big wire can. So when we talk about high voltage, how much does it take to have a bad day? Well, 1 to 4 milliamps, I might feel as a slight tingle. At 5 milliamps, I might feel a faint shock. At 6 to 30 milliamps, now it's a painful shock and I don't like it. At 50 to 150 milliamps, excessive pain, muscle reactions, including breathing. Death is unlikely, but possible, right? How is that heart condition doing? 1 to 5 amps. To put this in perspective, a brake lamp uses 2.5 amps. So we're not talking a lot of power here. The heart is shocked and will become erratic, making death likely. At 10 amps, that's your radio in your car. Heart is stopped, making death very likely. You get burns too, but that's a little like the radio not working when your car is on fire. It's beside the point. So, all kidding aside, yes, these are dangerous. Yes, these can kill you. At the same time, they're pretty safe as long as we follow good common sense practices, don't wrap ourselves in tin foil and stand in a bucket of water. I mean, so there's things we can do that really make this, that are just dangerous, like scrubbing your orange cables because you want them to be shiny. And there's things that just common sense keeps us safe. You think about it, the house that we have, where we live, has 110 volts in the walls. Well, that's in this range. May even have 220 volts in the walls. Certainly that can kill us, but we've seen electricians work on work on houses, and they're not killed. Not to say electricians don't die every year, they do, because they make mistakes, mostly working on real high power stuff. We got 10,000 volts. But you're not seeing someone suit up and having someone stand back up when someone's working on the electrical panel of a house. And so we're working with the same electricity in a car, very, very similar. So why do we have all these extra safety protocols? Well, because it's new. One of the safety protocols for working on hybrid vehicles is there's supposed to be someone else standing by with a body recovery hook in case you get welded to the vehicle. Well, needs to say that was the early rule. That's not followed anymore at the dealerships. It's not practical and it's not necessary. We still have the hook at school. It's required equipment, but again, something that when it first started, oh, you need to have this. You need to have a separate bay where only this is done. You need to have someone standing by in case you get shocked to pull you away from the vehicle. All these just over the top things, but gee, no one does. And yet electricians don't do it when they work on electricity on the house, which is 240 volts, which is in a similar voltage range and can also kill you. So different icons we have. Toyota uses a ready indicators. Many manufacturers do. Other manufacturers use an indicator showing your vehicle has both forward and backwards gears. The importance of these is that a hybrid vehicle will turn the engine off, will turn off the internal combustion engine. So when you pull it into a service bay, the internal combustion engine's off. It's real easy to think the engine's off, and then people start working on it, change the oil, work on the belts, put their finger plates, and the engine starts all on its own because it was in ready mode. So when we're working on hybrid vehicles, we really need to make a point of making sure we take them out of ready mode and we take the keys so someone else can't put them in ready mode. So there is some additional safety that we have on hybrid, because hybrid engines shut the engine off and start them back up. And, the car may be up in the air with all the oil drained out of it when the engine starts. Well, now, maybe the engine's going to be bad by the time we get it put down. So you can see where there is some, so we really need to pay attention to this. And I mean, I've had this happen to me in the shop where I've pulled in a hybrid. I'm talking to someone who catches me right as I pull in, and the engine's off, and I think I already turned the car off. And then I'm outside and I hear the engine start. It's like, doggone it, I forgot to take it out of ready mode. So, I mean, I'm very comfortable with this. I'm certified in it. And yet by getting distracted, I can still make this mistake. So this is really important. We also have different power mode options with hybrids in all vehicles, eco mode. We have that on vehicles that aren't hybrid, but we have EV mode on some of the plugins that tell it to work only on the plug-in and not turn on the gas engine. So there's different modes that drivers can select. But the big ones I was concerned about here was the ready mode, the ability to move mode. This means that the engine can start at any time. So we need to make sure it's not in ready mode when we're working on the vehicle. Let's take the last little bit and look at some automotive measurement, math, and testing tools we're going to be using in the class. And that'll get you guys all set. And then we'll be back in person on Thursday. So measuring systems, I put this in here really as a reference. And they use customary in the book, which I thought was funny. I hadn't heard it called customary since I was in school. We call it standard. We call it standard and metric. If I go into the hardware store and ask where the customary bolts are, I think I'm going to be probably chased around to a lot of people that have no idea what we're talking about. So this is normally called standard or imperial. This is your inches, pounds, gallons, and so on. So it is interesting. Again, this is where education uses a term that's the technically correct term, but it's not the term the industry uses. So it's really not helpful to be educated in something that no one uses. So that's why you're going to hear me call it standard normally. I don't even use imperial. Imperial is an old term. If I pull up a 1960s manual, I'll see imperial. Customary, I've only seen in school. And most vehicles today use metric. So some of the things we need to convert, sometimes pounds to kilograms, not that so much. Square inches to square meters, or cc, cubic centimeters. So we do that with engine size back and forth. So for example, my 460 cubic inch engine is 7.5 liters, right? So we a lot of times I got to go between standard and metric for my engine size. So we're having here liquid volume. We'll see some of that. Road speed, miles per hour versus kilometers. Where we see a lot of it is in specifications on torque. Some manufacturers only provide torque in Newton meters, while other manufacturers will only provide it in foot pounds or inch pounds. It is 12 inch pounds to 1 foot pound, kind of like 12 inches to a foot. Wow, that actually makes sense. So you will see inch pounds, you will see foot pounds. I see a lot of mistakes that entry-level techs make is they concentrate on the number and miss the fact that it's inch pounds. And I've had students take something and put a torque wrench to 70 foot pounds and start tightening up transmission pan bolts. And big surprise, they break because it's supposed to be 70 inch pounds. So sometimes torque wrenches get us in trouble because of scaling issues. They want it in inch pounds and we misread it as foot pounds, or it's in Newton meters and we didn't realize it's in Newton meters, or we did the conversion incorrectly. So that is an issue. We had an alternator damaged just before we left campus, I was out doing some other training and had a substitute, and my class was changing alternator. We've done several times, and they broke the bolt on the back of the alternator using a torque wrench because they put it on the wrong scale. In the field, things like that, we don't even use a torque wrench for. It's all by feel. One reason why we use torque wrenches a little bit more in school is to give you guys that feel, but sometimes trying to get that feel actually creates problems. Torque, foot-pounds or Newton meters. Power, horsepower is normally what we see for gasoline engines, and kilowatt hours is how we'll see power displayed for hybrid and electric vehicles. Pressures, we do a lot with pressure where we go between pounds per square inch, kilopascal, and bar, which is 1 bar is 1 atmosphere. So manufacturers, many European manufacturers give specifications in bar. A lot of Asian manufacturers give it in kilopascal, and a lot of domestic manufacturers give it in PSI. So you will see those things change quite a bit between them. We also look at converting pressure between inches of mercury, inches of water, and millibar. So those are very sensitive ways of measuring pressure. To give an idea, it's 33 and I think 3/4 or 33.5 millibar per PSI. So you're talking a very, very small amount of measurement. So as we do some scaling, we use some different ways. When we measure pressure that's less than atmosphere, we use what's called vacuum, and we normally measure that in inches of mercury, or if I want to be more sensitive, inches of water. So we are going to be doing some of that when we get into some of our engine management. Temperature, Fahrenheit and Celsius, the scan tool is able to display diagnostic data in either scale, whatever you're comfortable with. However, sometimes manufacturers only list it one way, so you have to do the conversion. And it's also important when you look at 90 degrees, am I talking Celsius or Fahrenheit? Because if that's Fahrenheit, I have a cold engine. If it's Celsius, then that engine's at normal operating temperature. So you do have to pay attention to how things are being displayed. So I did also put a conversion chart in here. So we can convert, length, pressure, volume, mass, and speed. So I've got some quick things. The torque one is probably the one I use the most, which is Newton meters to foot-pounds, because all my torque wrenches are in foot-pounds. So if the scale's in Newton meters, I'm converting to foot-pounds. So I remember that one. I never go the other way because my torque wrenches are all in foot-pounds. Why would I go the other way? Pressure, we do a little bit of stuff on. Speed, miles per hour, we'll do some stuff on because sometimes manufacturers will write documentation in kilometers as far as when things are supposed to turn on or off, or when things are supposed to happen driving down the road, and I need to convert that to miles per hour in order to understand so I can test it. So those are some of the conversions. Another conversion we use a lot is going between metric and standard and decimal. So here is my metric over here on the end, millimeters, and here's my inches, and here's my fractions. So I'm actually old enough that when they used to make 3/4 sockets, when metric first came out, Snap-on socket said 3/4-19 millimeter on the same socket. And we can see here that 3/4 is just under 19 millimeters by just a smidgen. 7/8 is a little bit bigger than 22 millimeters. 5/8 is a little bit smaller than 16 millimeters. 1/2 inch is a little smaller than 13. 3/8 is a little smaller than 10. And 1/4 is a little bit bigger than 6. So you're kind of wondering, why are you bringing that up? Well, it's important in that an 11/16 wrench will fit really loosely on a 17 millimeter fitting, because it's 1/2 millimeter too big. So we have a lot of vehicles on the road that some of the stuff underneath the hood's in standard and some of it's in metric. So as we're using fittings and as we're taking things apart, if I'm putting on 11/16 and it's loose, I need to think, wait a minute, maybe that's a 17. Let me try a 17 on it. Oh, that's snug, because if I use that 11/16, I risk rounding out the fastener and damaging the fastener. Now I have a problem because now I have this bolt that's tight and the fastener is round and it doesn't want to come out. So a lot of things, the difference between 3/8 and 10 millimeter. If I'm used to working on 10 millimeter, which is very, very common today, If then I get to a 3/8 fastener, or 3/8 fastener is slightly smaller, I can round off that 3/8 fastener very easily using a 10 millimeter socket. So in order to be efficient, I need to kind of know where things are at. So this is actually really useful. I don't have all of these memorized. I kind of start at 3/4 19 millimeter. I know 17 is about 11/16, 7/8 is about 22 millimeter, 13/16 is about 21 millimeter. So if I'm trying to take lug nuts off and 13/16 doesn't go on, and it's just a little tight, maybe it's a 21 or a 22 millimeter. On the other hand, if I put a 21 millimeter socket on my lug nut and it's loose, I probably should go get a 13/16 because that means it's a 13/16 nut and not a 21 millimeter. So this is really helpful going back and forth as we are working on vehicles, understanding the conversion between standard and metric sizes when it comes to our tools. Because if we fail to do that, yeah, can I get a 1/2 inch nut off using a 13 millimeter wrench? Yeah, probably 80% of the time I can, maybe even 90, with a little bit, with some damage to it. But there's going to be a good 10%. It's not going to come off. And now I've just rounded it off where even the 1/2 inch isn't going to take it off. Now I have a problem. Now I'm having a bad day. Or how about going the other way? I'm tightening it up and then it slips just as I really start getting it tight. Where does my knuckle go? It goes into something that's probably going to hurt my knuckle more than whatever I hit. And so, these are ways we avoid getting hurt, is by making sure that we have the right wrench or socket on the fastener we're trying to take off, the right tool for the job. I have a substantial investment in tools that I've made over 40 years. And people sometimes, as we talk about tools, gee, why do you have that brand of tool? Because I made my living with it, because that's the one that really makes a difference. It just feels different. I get hurt less. I have fewer rounded fasteners. I have these things. Does a tool that costs 1/10 the amount do the job? Yeah, it does the job 90% of the time. But I need better than 90% of the time if I'm going to make a living with it. So there's tools that are fine for doing around the house and understand you're going to have issues or things might be harder. And there's definitely a difference between that and professional tools that get to that next level. I mean, and I'm a little spoiled because I use those all day at work. So I'd actually buy professional tools to use at home, even though I'd hardly ever use them at home, because it was so frustrating not having good tools. And I think that's true with anything you do. I mean, the difference between a good pan or good cookware and bad cookware, there's a difference in cooking with that. The difference in, a lot of things we have. When you have knives, if you're cooking and you're using knives, a good chef knife is very different than a $7 or $12 chef knife. I mean, there's a difference in using that tool. Difference in feel, difference in performance, difference in safety, difference in quality of outcome. And tools are the same way. So that's why I put this decimal conversion chart in there. And you can see 1 inch is right about 25 millimeters. So I know the common ones that we see a lot, because there's a lot of 17 millimeters used, a lot of 16 millimeters are used today. We see a lot of 3/4. 18 millimeters is a common wrench size today, but we don't use 23/32 anymore. So a lot of times if you put a 3/4 on or a 19 on and it's loose, you're just going down to that 18. But that's important. The other thing we do is we do a lot with our number symbols on the meter. So if I look at micro, 1 millionth of, milli, 1,000th of, my actual value, kilo, 1,000 times, and mega, 1,000,000 times. So what this means, and we're going to be dealing with this next week when we start dealing with electricity, because meters like to auto range and they'll change these scales. So what I'm looking at here is I have 1,000,000 micro, 1,000 milli, 1.001 kilo, and 0.000001 mega. These all mean exactly the same thing. These are all one. These all represent the exact same value. They do it different ways. And our meter, when we're measuring electricity, may jump from 1 to kilo to mega. It may go down to milli or micro. It may jump up and down, do what we call auto scaling, and you don't realize the scale has changed. Sometimes we're measuring something on the wrong scale. So when we read specifications, they give us a number. Maybe they give me a number of 1.3 ohms, 1.3 kilo ohms, excuse me. Well, that'd be 1300 ohms. So I could get 1300 on the 1 ohm scale, or 1.3 on the kilo ohm scale, or 0.013 on the omega ohm scale, right? So, I mean, what scale am I on is going to determine, because my meter can only read out a few digits. So I need to use scales to allow it to read this huge range of data. This is also important when we're looking at signals on a scope and we're looking at how fast a signal, because now we're going to apply some of these to time, milliseconds and microseconds to time. So I have seconds, but then if I want to break a second into 1,000 parts, that's milliseconds. We routinely do that in automotive and electrical signals. We're actually measuring things in milliseconds. Some things are only turned on for 2 milliseconds or 3 milliseconds. And I need to be able to see that and measure it and see if it works right in that time. Then we have things that are microseconds, and there's actually circuits on the car that work in microseconds that I actually have to be able to go in and see what's happening over a period of 100 microseconds, 500 microseconds, and to determine and do those tests in that short a period of time. And so it's important to understand what these times are telling me, how fast things are happening, so I can both use the meter and a lab scope with proper scaling for testing the circuit I'm trying to test. Because if I'm testing a circuit that works very, very fast, but I'm measuring it in seconds, I'm going to only see noise, or I might not see anything. On the other hand, if I have a circuit that moves very, very slowly and I'm measuring it in milliseconds or microseconds, I may never see anything happen because I'm just sampling too fast. So we use this for both looking at time. We use this for voltages a lot and some other things. So we are going to be doing a lot with the up and down on the scaling. So this is something that normally people struggle with, having taught electricity for a lot of years. And it is something that by the best way to get over the struggle is you're not going to memorize this. You're not going to go home and I'm just going to memorize. You'll forget the next day. But by using it and applying it, that's how we remember it. And the best way to use and apply it is on the labs that we're doing on campus, because this is what we're going to be applying. Calipers, vernier calipers, are used to make rough inside and outside measurements or depth measurements. So if you guys took brake and suspension class, I might use these for measuring a rotor or a drum. So this is where I don't need necessarily extremely high accuracy. I need to get close enough. And these are pretty accurate. If I want more accuracy, I would use a micrometer, where I'm down to 1/10 of 1/1000th of an inch in accuracy. We have internal and external micrometers. So there's a difference between a caliper and a micrometer. Calipers is all we need most of the time, unless I am doing machine work on an engine, or I am, we'll see some valve adjustment, checking some shim thicknesses, things like that. I'm going to want to use a micrometer. A lot of things we can get away with a vernier caliper. I don't need that much accuracy. If I'm off by 1,000th of an inch or 2,000th of an inch, I don't care, because I'm measuring pretty big numbers. Micrometers continued. We have inside micrometers for measuring large holes, cylinders, port openings, depth micrometer for measuring how deep a hole is. And then if you notice, these are mechanical, not digital. I actually prefer the mechanical ones because the batteries keep going dead in the digital ones. And read a mechanical micrometer. I do not get into this heavily in this class. I don't even cover the chapter on it really in this class. It is in module in ASE 0 in CDX, and I give you access to it. So if you want more access, if you've taken the intro class, they spend a lot of time on this in the intro class. So, I expect some familiarity with this. That being said, we're not going to be doing any measuring with micrometers in this class. We're not rebuilding engines, and what we're going to be doing is we really concentrate on electricity here, because that's what we use. If I tell you, I have quite a few micrometers. Most of them collect dust. compared to my meter or my scope that gets used every day. So if I'm going to teach you the tools to use, I'm going to teach you the tools that I use every day, not the tool I use once a month, right? What's a better use of time? We need to know these tools are out there and what they do, but they're not something we use every day. So in this case, the 1 represents 100 thousandths. Each of these smaller lines represents 25 thousandths. And then we have 3 graduations after that. And we get to the 3. So that's where we get to the 178 here. And this is really bad how they did this. Because really, if you're reading this, you're probably over that last line at this point. Because if you're at 178, you're going to be much closer to this 3rd line. But they exaggerated this. This is not what it would look like on a real micrometer. For a micrometer, you're going to be just over the line because you cross the line at 0. But they exaggerated this to show the point. Feeler gauges, we will talk about feeler gauges when it comes to engines and valve adjustments. These are used to measure small clearances or gaps between parts. A couple of different types of feeler gauges. These are steel feeler gauges. We also make brass feeler gauges, which are used for setting gaps between something that has a magnet to it, because I can't use a steel feeler gauge. So some of our sensor pickups and other things require a brass feeler gauge. You can see these are in metric and in standard. These are straight feeler gauges. I also have feeler gauges that are bent at 45 degrees and feeler gauges that are bent at 90 degrees. So we have different styles. So we use these still for valve adjustment. It's probably the most common thing we use feeler gauges for. The other thing we use them for a lot is measuring if I have a warped cylinder head or cylinder block when I'm doing a valve job or a head gasket job, things like that. We'll use this in combination with a straight edge. So we use these still quite a bit. These are an inexpensive tool. You don't use them every day, but they still have some uses, even though they've been around for a very, very long time. A dial indicator. Here we're using a dial indicator to measure the rise of a lobe on a camshaft. So if I think I have a flat camshaft, I could do this test. And this is an old school way of doing it, which is appropriate because that happens to be an old engine. That's a Pinto engine, is where that was originally used, also used in Ford Rangers. This is how we would find this out back in the day. And back in the day, if I thought I had a flat camshaft, I'd have to take the valve cover off, everything off the top of the engine, set this up, and start comparing against specifications to see if my camshaft's flat. Or sometimes it's so bad I could see it's flat. Today, we're not going to do that. Today, because it's a lot of labor to take the engine apart to get to here, I need to figure out the camshaft is flat before I take the engine apart. So we're actually going to use a pressure transducer and a lap scope to figure that out. So again, this is what I talk about by diagnosing things externally versus diagnosing things internally. Old school, take it apart, use a tool. New school, how do I figure out what's wrong without taking things apart? Right? And which is more efficient, because if I'm wrong, I've taken all this apart, spent a lot of time, I got to put it back together before I can go on diagnosing. If I can figure out what's wrong without taking everything apart and I'm wrong, guess what? I know what the problem isn't. Now I can quickly move on to what the problem might be. Pressure gauge, we are going to be talking about pressure in here, both compression pressure, fuel pressure, oil pressure. And so this gauge reads PSI. We also see that it reads bar. And so on the outside of the scale, we have PSI. On the inside is bar. We got 2, 4, 6, 8. Each bar is 14.7 PSI, which is 100 kPa. So I put this in here just as some quick conversion. This gauge reads what's called gauge pressure. That's why it reads 0 at atmosphere. The 2 types of pressure we measure is absolute pressure, where currently we have 14.7 PSI if you're at sea level pressing on you as you speak. We're just used to it. Or you have gauge pressure, which reads 0 at whatever atmosphere you're at. So my gauge is going to read 0 whether I'm here or whether I'm in Denver. If I'm reading absolute pressure, I will have less pressure in Denver than I have here because there's less weight on me. As you go up in altitude, there's less pressure. So on the vehicle, we have sensors that measure gauge pressure, and we have sensors that measure absolute pressure. when we do testing, the only thing we have to test with, I shouldn't say that. Most of what we test with uses gauge pressure. We do have some transducers that can measure absolute pressure. But for the most part, everything we're using measures gauge pressure. So I need to be able to convert gauge pressure to absolute pressure. If I'm below 0 PSI gauge pressure, then we're in what we call vacuum. So vacuum goes from 0 to 30 inches of mercury. At 30 inches of mercury, that is 0 absolute pressure. So when they talk about the vacuum of space, it's not that it's vacuum, it's that it has no pressure. It's less than atmospheric. So I can measure it in inches of mercury like I did here. I can measure it in inches of water like I did here. Because inches of water weighs less than mercury, therefore I would get more inches of water with less vacuum. So so we use water for a much smaller measurement than when I would use inches of mercury. So if I'm diagnosing the engine, I'm as far as the intake system or how the engine's running, I'm going to use inches of mercury. If I'm diagnosing the crankcase system, I'm going to use inches of water or millibar. If I'm diagnosing the fuel evaporation system or fuel tank for leaks, I'm going to use inches of water or millibar, because inches of vacuum would be too much vacuum. I damage components. So we have different scaling that we use. That's why we have different tools. We also talk a lot about angle measurement and 360 degrees in a circle, and then going to do circles. And I see Jessica has a question.
I've seen some gauges with water inside the gauges. Does that change
Okay.
how things are read?
So actually, those are not water. What it is, it's a glycol solution. And what it is they're on expensive gauges, and they're used to keep the needle from bouncing so much. So they're actually used to stabilize the reading.
So they're better.
You will see high-end gauges. You see it especially in the scientific community. We don't really use liquid-filled gauges for automotive, but you will see them for scientific stuff, and you'll see them in industrial applications where it's a liquid-filled gauge, and it's actually they're using a glycol in that, and so glycol or glycerin. It might probably glycerin. But you get the idea. So it's not actually water because of the corrosion issues. So they're using usually a glycerin or glycol type to do it, but it's there. A kind of keeps everything nice and lubricated. You don't get corrosion from atmosphere that you might get, especially if you're by the ocean or something like that, where you're going to get a lot of salt air. So it keeps it a sealed gauge. The other thing it does is it dampens some of that needle movement. So you're not going to get this with it. It's going to dampen some of that and allow it just to move and be steady. But so in automotive, all of our gauges are just have air in them. Good question. So again, angle measurements, we are going to spend some time with angles, especially when we get into engines and we talk about when valves open, when valves closed, our relationship between our different cylinders, and how we pull in fuel, burn fuel, and exhaust fuel. And that all relates to degrees. And then we use those degrees to connect our crankshaft to our camshaft to our valves inside the engine, and when things have to happen at the correct time. And that's all done by degrees, including when we're going to put the spark or put the ignition to the spark plug is also done by degrees. So we're going to be spending some time with degrees when we look at our ignition system. So this is something we are going to be spending some time with on that and using it to just determine relationships of components. Temperature measurement. The computer has to know the temperature of many things, whether it's the transmission, the air, the coolant. And so we have temperature sensors that are going to convert an actual physical temperature into an electrical signal that the computer can understand based on its programming and figure out whether something's hot or cold. A lot of things on the vehicle are extremely temperature related. We also manipulate, manipulate the temperature of things. And what I mean by that is, for example, here we have water. So water freezes at 32 degrees and it boils at 212, or if I'm in Celsius, 0 and 100. What if I told you I can make water boil at 60 degrees Fahrenheit? Right here in this room, I can make water boil at 60 degrees Fahrenheit. Well, wait a minute. We were all taught that water boils at 212.
You would be right, because it would be about 140 degrees Fahrenheit.
Right.
60
well,
degrees Celsius. It looks like it's below 160
right.
on the
No,
Fahrenheit.
but
side.
I'm saying 60 degrees Fahrenheit. I can boil water at 60 degrees Fahrenheit.
You can with maybe with coolant.
Well, no, you're starting to think out of the box. So I like that. So this chart is based on 14.7 psi holding those water molecules together. What if I put that under 30 inches of mercury and I now no longer have any pressure holding those water molecules together? Now it's going to take less temperature to evaporate them. And that's actually why we use vacuum on air conditioning systems to boil the water out of the AC system, because at 30 inches of mercury, we're boiling water. I can boil water at 60 degrees Fahrenheit if I put it under vacuum. So on the other hand, if I put my water under pressure, I can keep it from boiling at 212. And that's why your cooling system is under pressure on your vehicle, is so water can't boil at 212. So I can use pressure to manipulate the temperature that substances change from liquid to solid or liquid to gas. So the things we say that we know, well, what we know is water boils at 212 at sea level. Well, why is it at sea level? Because that's when we have 14.7 psi of pressure, one baro holding that molecule together. And in order to get enough expansion to break that apart, I need to get to 212 degrees. If I'm at 30 inches of mercury, I don't need to be at 212. So pressure has a direct effect on temperature, and that's really important in the automobile. I mentioned air conditioning, which we teach in the 507B class, but it's also really important for fuel. It's also really important for air. So there is important for my cooling system on my car if I don't want to overheat. So we're going to see how we use pressure to manipulate and control temperature of things, and how temperature affects density. So, which again, as density changes, pressure can change. So there's a lot of moving parts here when we talk about engine management and how this all comes together. So, you know, when you're kind of going, so temperature is not as simple as, oh, water boils at 100 or 212. Hey, that's good to know. I got a conversion factor. Really, what I want you to take away is water doesn't always boil at 212. We can manipulate that, and we do. And so let's concentrate on how we can manipulate that, because that's how cars work. And that's how we can apply that knowledge and figure out when things don't work wrong. Because what if I have a car that's boiling over because the water boils at 212? When in reality, that car's supposed to operate at 230 degrees. Well, the water would only boil at 212 if I can't keep pressure in the cooling system. So maybe I don't have a water problem or an engine overheating problem. I have a pressure problem where I'm not putting the pressure in that I need in order to increase the boiling temperature. So you see where I'm kind of getting a little out of the box. So Jessica, you were on the right track. You were starting to what? Play with a variable. And the question is, which variables affect this? And that's really what cars are all about. Is like, you know, how the variables affect each other, because nothing is in a vacuum. Nothing is just, hey, it's only this, learn this, compartmentalize it, go learn something else, compartmentalize it. Everything affects everything else. So we need to look at how, when we move one thing, how are other things affected? And this just kind of opens up to the discussions we're going to have throughout the class. Torque wrenches, here's old school. We don't use these anymore. I'm sure they still sell them. This is a dial. This is a click type. And one thing I don't have here is a digital. Newer torque wrenches that they're selling are digital, and they also have a built-in degree, so I can measure how many degrees I've turned after I've hit the max torque for doing modern fasteners. I should grab a picture and throw one in. So I have one digital one. I really don't use it. It's an older digital one, but they came up with a really neat one that measures the degrees. I wasn't doing heavy line work anymore, and they're about $450, $500 for a good one, so I just decided not to buy it. I have an old school way of doing the degrees, so I can still get there. But I have the dial indicator ones, and there's certain things that a dial indicator one will allow me to do, such as measure the amount of rotating force on something. So if I'm building a differential or building an engine, I want to measure the drag as I turn something around to make sure it's turning freely or turning within specifications. I would need to use a dial indicator wrench. And then we normally use click type wrenches, where it actually pops or clicks when we hit a certain torque amount for securing fasteners. And that's kind of clicks away, because that way, a lot of times I'm using a torque wrench in a position where I can't see the scale. So that click lets me know I've gotten there. The newer digital ones will actually vibrate as you get close and then sound off and vibrate when you hit the spot. Very high tech. I have, what do I have on my box? I probably have 7 different torque wrenches, I guess, in my toolbox that I use. I have quite a few. I have 2 dial ones, 1 twist one, 3 clicks, and then a digital, which is a click. So yeah, I guess that's about 7. So, I mean, that's how many torque wrenches I have just to be able to do the things I need to do. And I didn't go buy the new big dollar fancy one that if I was still doing engine repairs, I would have bought. I got to the point in my career where I no longer did those things. I was doing more diagnostics and high level stuff. And if I diagnosed an engine that came apart, it went to someone else to do the hard, heavy work who's younger. Torque angle is what's in it. So these are for torque to yield bolts, Christopher. So a torque to yield bolt is a bolt that will give you a specification where it's and they're stretch bolts. So what they do is they say, crank it to 90 foot-pounds plus 60 degrees. Or plus 60 and then plus 60 or plus 90, but they'll give you a degree measurement after that final torque. And those are a torque to yield bolt, also called a stretch bolt, because what you do is you put that first torque on it, then you give that extra turn, whatever the degrees are that the manufacturer specifies, that actually puts some spring tension on that bolt to help keep things together. Those are also one-time use bolts. So Porsche is using them now on their brake calipers. So the brake calipers on some newer Porsche models are a one-time use bolt. They're a throwaway bolt. So the new digital torque wrenches, not only are you able to dial in what torque you want, but you can also set up the degrees and it'll walk you through and let you know when you hit the number of degrees you want. I have an old degree wheel that goes underneath that measures degrees, and I got to watch the arrow go around. You can also mark the bolts. There's other ways of doing it. So I still have the old school ways to get there. The new ones are nice. The friends of mine that are doing a lot of engine work have bought them because they make sense. But they're pricey, but that is what it is. So that's what we're talking about. We're talking about the torque angle, how many degrees after the final foot-pound setting, and that's for a torque to yield bolt. So did I get that okay for you, Christopher?
Yeah, no, you did.
Okay. So a test light is a tool that's been around for a very long time in automotive, and we really don't use it anymore. And one of the issues with a test light is it actually creates a circuit. Depending on the test light, it can actually damage or destroy a computer. And it is not really testing the whole system the way we want to. So it allows us to make some really bad decisions and get confused. So about 20 years ago, a product came out called a Power Probe. And this is great. Is because it allows me to see both power and ground. It's connected all the way back to the battery. So now I've got a good electrical connection so I can test, am I missing power? Am I missing ground? It also gives me the ability to apply power or apply ground at the tip. So I can actually power up a fan or power up a light bulb or power up things. If a fuse is blown, I can use it to power up to see, does it blow right away? Because there's a 10 amp circuit breaker built in. And it also has this extra alligator clip right here, which has ground. So now I could hook this to one part of a light bulb and this to the other part of the light bulb and turn the light bulb on to test, does the light bulb work? Does the motor work? Does the solenoid work or anything else? So this has really replaced a test light in the shop. So we really don't use test lights anymore. We use Power Probes. And I have these for campus. So we'll get to play with these a little bit. We use a digital voltometer or digital multimeter, depending on your term. So we'll be using these next week. I got 25 brand new ones just for our labs. So the labs we're going to be doing this class exciting because I have had the opportunity with COVID to purchase a tremendous amount of new equipment for doing our labs. So you guys are going to be the first students to get to use a lot of this stuff, which means you're going to have new equipment to use. Ricardo, are you going to be at campus on Thursday?
I will.
Okay, I'm going to be down there about 11:30. I'm supposed to get the trainers delivered on Wednesday. And so we're going to set that classroom up on Thursday and have it ready so I can see if I need to go buy more extension cords or anything.
You got it.
Trying to get things ready. I don't want you guys showing up and we spend an hour trying to find and unbox and get things working. So I want things ready to go for you guys. So I'm going to drive down to the campus and do that. So these have the advantage of having high input resistance. 10 mega ohms is the minimum standard. So 10 million ohms of resistance, which keeps these from becoming part of the circuit. It allows us just to test the circuit, unlike a test light that has very low resistance because it's light in a light bulb. These are multifunction, so they allow me to measure volts, millivolts, ohms, amps, milliamps, quite a few things, as well as some special functions that might be built in. They're also Cat 3 and Cat 4 certified. So Cat 3 is up to 1,000 volts. Cat 4 is up to 600 volts. The difference between the two is the amount of amps. That's why Cat 4 has a lower rating. It's designed to handle higher amperage. So these means that these are safe to work on either my home electric system or on hybrid or electric vehicles. If you're using this on a hybrid or electric vehicle where you need that Cat 3 or Cat 4 standard, you need to make sure your test leads are Cat 3 or Cat 4. It doesn't help to have a meter that is made to work on that high voltage. If you have leads, they're going to bleed that voltage through to you. So that is important. Then we have their next two, which would be a graphing multimeter or a digital storage oscilloscope. This has both built in. So here's an older example of a Snap-on Vantage. And what the advantage of this is it still has that high input resistance, still is very accurate. So this basically does a lot of the basic functions that a digital voltimeter does, with the advantage of being able to look at things happen over time. So what I'm looking at here is I'm looking at a voltage scale of 0 to 1 volt. And I'm looking at how that voltage is changed over 5 seconds. And then I can go in and actually measure that change. So I have the advantage of seeing how something happens over time, which means this allows me to go in and look at faster and faster signals, as well as compare signals. So today, even though we're going to start with a digital multimeter to kind of get you guys used to some of the testing, we're going to be quickly moving on to digital storage oscilloscopes, because in my toolbox, my digital multimeters I didn't even keep the batteries in them anymore because I used them so little, because we use almost exclusively a scope now, or a graphing multimeter. So what we have at the campus is the new version of it, the Vantage Ultra. And we can see here where not only am I able to look at something over time, we have a lot of settings, but I can look at 2 things at once. Where a digital multimeter, I can only look at 1 thing at a time. Here I can compare 2 things at the same time, which is huge. And so we have some exercise that we're going to be going through, and I actually have little simulators that are the whole engine, and we're going to be looking at through the major inputs to the engine when we look at computers, and actually looking at how they work, looking at how to test them, and we're going to put some faults in them and actually see what things look like when they don't work. And this is going to give you guys the confidence of using the tools before we go out and actually try to use the tool on a vehicle. Because when you're confident with what the tool does, and you go up to a vehicle and something doesn't work right, you know it's a bad vehicle. If you're not confident with the tool and something doesn't work right, you don't know, is it the tool, the connection, or the vehicle, and you're flying blind. You don't know because you don't have that comfort level with the tool you're using. And so this is going to be really designed to get you guys the comfort. So we have enough of these for everyone to be most likely using one, because I have a total of 20 trainers. So we'll see how many people show up, attendance, all that. Right now, we have just under 20 people in the class. So I have 20 different stations. So if there's 20 people or less, everyone gets their own. If there's more than 20, then we're sharing. But it won't be more than 2 people to a trainer and a scope. So it still allows you a lot of hands-on time. So you can imagine quite an undertaking of getting 20 of everything. So this is a mega ohm meter. These are used exclusively for testing hybrid vehicles for what we call insulation leaks. This is where we're worried about that high voltage getting out of the high voltage system. And so we use a mega ohm meter to test that. Because you heard me, the high impedance is 10 milliohms, 10 million ohms of resistance is high impedance. It's not part of the circuit. When we start looking at high voltage, when I do a test on like a hybrid vehicle, like a Prius or something like that, I'm looking for an insulation fault. I'm looking for anything less than 550 million ohms of resistance. So the scaling is just exponentially higher. And so we need a separate tool for that. And so, that's why it's important to know what tool to use for what job. If I try using the wrong tool, I'm going to make bad decisions. I could potentially damage the vehicle or hurt myself. So I wanted to kind of give you guys an overview of some of the tools we're going to be using in class and that you're going to be exposed to during the class. So with that, that's everything I have for today. I'll make sure that the assignments that I talked about are turned on. And any questions before we call it a day? Also, I'll remind you, I did send the announcement out that we do not have class tomorrow, but I will see everybody on Thursday because I need to do some training with the state tomorrow.
I have a question.
Sure.
So instead of, we don't have class tomorrow,
Correct.
so we'll be online again on the Zoom on Thursday.
Correct. Yeah, we're
So-
normally going to be on Zoom Tuesday, Wednesday, Thursday. This Wednesday is an exception because I need to do some stuff with the state of California. So, occasionally that happens during class where I have a day that I have to go up and do some state stuff with the state. So I think that's probably the only one I have this class. But that does occasionally happen. So in this case, we're not going to have a Zoom. So you have all the assignments on Canvas to do. So you could take the 2.5 hours tomorrow and get caught up on the assignments. So again, this is just an opportunity. So there's plenty of stuff to do, but I will see everyone back in Zoom on Thursday morning at 7:30. I did send an announcement out about no class tomorrow and reminding to see everyone again on Thursday.
All right. Thank you, Mr. Bryan.
You bet. And Matt, did you get your registration handled? I don't see you on my list, but I saw the email to you from Eddie. Okay, I guess Matt doesn't have an answer.
Mr. Bryan,
Yes.
just a quick question.
Sure.
I didn't get the chance to complete the assignment yesterday. Do I still have the opportunity to do it today and still
Yes.
submit it?
Absolutely. So you saw the assignment that was due yesterday. If you didn't complete it, you got a 0. And what I explained yesterday, and for those of you that didn't hear it, I'm happy to go over it again. In my class, with the exception of the 2 tests, any assignment can be turned in until the midnight, the last day of class for full credit. So the due dates are there to help keep you on track. They're not there to penalize you because we all have different schedules. We're all doing different things. So they're there just to keep you on track so that you don't fall behind. So you can do that assignment today. And you still get 2 chances at doing the assignment and still get full credit for the assignment. So I don't do any penalties. Some instructors, and I've done in the past, and when we were on campus full time, I did have some penalties, but I had a lot fewer assignments and people's schedules were not as hectic. So what I do online is there's 0 late fee, 0 late penalty for turning in something after the due. The only reason why you see your score go from nothing to 0 is because you've passed the due date and you haven't turned anything in. So you can see how not doing that assignment affects your overall score grade in the class. And I mean, I literally have had students turn stuff in at 11:58 the last night of class. And by the way, the last night of class is Saturday, January 22nd. So even though we don't have class past Thursday, because it's online, the last date of class is Saturday night at midnight. So you guys get till that Saturday night to turn stuff in. Yes, Jessica.
Did we have something due yesterday?
Yeah, it was the syllabus and policy homework quiz.
Okay. I
And
guess
that's
I'll
the-
do it late.
Yeah, no worries. And that's the other reason why I do it, because normally Canvas will let you know as soon as you log in, hey, you have an assignment that's late. You have something you missed. Or it also tells you when I grade it. So when I grade it and put a 0, you get, hey, you just had an assignment graded. So I use all those as reminders that, oh, you missed something. Let's get it done before it becomes a problem. So it's not there to penalize you. It's just different ways I have of trying to remind you that we have these different assignments going. So your grade, you know, if I look at you at the end of the semester and half your classes say they were turned in late because they're highlighted in red, which is a poor color, but they're highlighted in a different color, it has 0 effect on your grade for this class. So again,
Hello, sir.
I try to be really, really fair about that because I understand everyone's schedule and everyone's workload. And again, I'm a big believer. If you don't do the assignment, you can't learn. And I've had teachers that, gee, if you turn it in 3 days late, it's only worth 30% instead of 100. There comes a point, why do the work, right? Well, if you don't do the work, you don't learn. I'd rather you learn. I mean, that's why you're here. So let's just help you remember to do the stuff.